Hey everyone. I've been hurriedly slapping together things in OBS to get some kind of layout that would work okay. Okay, we're up on YouTube too. Waiting. Oh, Zach might be here.
Hey Don, you there?
Hey,
What's up?
nothing much. How about you?
I'm doing great. I'm gonna pull in the audio. I think audio is working.
Okay.
Um, so I'm getting excited, and I got to go and find out what your what do we got here. I was just pulling up Twitch to have you on here as well, so I can see your. Uh,
Oh.
oh crap! There's an ad. Hold on, bad.
Thank
I
you
want
for
to see
the
what
two
you're doing.
cents.
Yeah, I got to see what's going on. So get through the ad. But yeah, I'm excited for today. I saw you've been training, and I have not been training. So
Well, it's because I
there's
hardly
that.
ever code these days, so I needed
Yeah.
to remember it.
Although I will say I was going through some old Project Euler questions, and I remember I showed you the poker one, and I was showing
Mm.
my brother-in-law the same problem, and he's a programmer, and it was like the things out we were talking about the string comparison and how you just use the overloaded operators and good times.
Yeah, that was really clever. I forgot that Python works like that,
Yeah.
comparing strings.
Yeah. I don't know if we'll need that today, but we'll see. I'm excited to see what we got because I mean, I literally am going in blind. I have no idea what I'm going to be seeing today. Rapid and
Same
try
here.
catch, it never breaks. It's true. Corrupt converter. I give that to you, Don. Just try catch everything. Well, oh, me and Machi Rex, what's up? Glad to have you here. Um, so I guess we're waiting for Dr. Cook. Is that right?
It sounds like it. Have you already talked about like the format of this? Because I have not yet.
Let's do that now. Are you live and ready to talk about
Yeah,
that?
I'm
Okay.
streaming and everything.
My understanding is this, and you can correct me if I'm wrong,
Mm-hmm.
that we have five problems,
Phobos,
and
thank you
it's
so
going to
much.
basically be a best of
Hope you're
five
well.
situations. So the first person to solve three correctly wins. If we end up with a 2-2 tie, there is a short fifth question. The fifth question is supposed to be shorter than the other four um, to determine a winner. Is that the idea?
Right. So we're both working on the same problem at the same time, and then we both move on to the next problem at the same time. Or whoever completes it first is when we move on.
Right. That's right. And I will share my screen so you can all see what I'm doing because that's important, right? Um, Uh, join voice Dr. Cook on my server. I think that'd be best. Anyway, so yeah, I've got my open window. Programming language, I believe anything goes. So if you have a language you prefer, I don't care, and I assume the reverse is true.
Right. I'm using Python, and
Okay,
I
cool.
want to, can I say that you have to use like machine code?
I'm no, I'm not Matthew. I don't know. I don't know how to do assembler that well. So, for those of you who don't know, there's a streamer that's in our little community who does everything in assembler. And I am not that person.
Can
I
you
I did
render
assembler a very long
LaTeX and
time
VS
ago, and I've
Code?
forgotten a lot of it. So, and you'll probably see me using an API a ton today. We'll see. I'm still deciding which language I'll use. It sort of depends on the problem, I think. So.
Oh, you're still deciding.
Um,
Oh, okay,
I'm still
that's
deciding.
cool.
Yeah, I don't know what's going to happen. We'll bring in Dr. Cook. Here we go. Dr. Cook, welcome.
Hey, what's
Hey
up?
there.
Hello.
How's it going?
We're doing well. We're
Good.
just going through rules and stuff. I know we had a chat prior to this, like a DM, and I think we're settled on everything. Is that correct? Did we decide on the five? It was five problems, not four.
Yeah, so we have five problems, and I think you correctly said it earlier, but I'll say again, the first four are the real meaty ones, and I think I was suggesting maybe 45 minutes, but maybe you guys want to play it by ear for the four problems. And
Okay.
then there's a fifth final tiebreaker, which I think we could cap at 10 minutes, and it'd be good.
Okay.
Uh,
Sounds good.
there was one other point I wanted to discuss before we got going. When you program, it's pretty common to Google things. Do we have restrictions on that? Because I
Oh,
don't know.
So I think for me, I think we should not. I think you can't copy pasta for one. So like, don't go to Stack Overflow if this has been solved before. Don't go and just like copy everything. Um,
Could
I
you go
think you
to
can
like,
use I think you can use an API as reference. So whatever
what about
language
like
you're using.
what about a Wikipedia page for a relevant math concept?
I'm good with that, Don. Are you?
Yeah, so as long as we don't Google the actual problem, and I guess if I happen to find the actual problem, I wouldn't look at it. But like, I'm definitely gonna need to Google like just some Python syntax things or something like that. So
And I promise
Sure.
you, I will too. Like whatever I do, I actually haven't
Okay.
decided on my language yet. So it just depends on what we get.
and I guess
Well,
for help from chat too, I think it's a related thing. Like
mm,
I'm kind of okay with maybe like nudges from chat, because it's
Sure.
good to have some like inclusion, but I don't want someone to like code the entire thing for me for sure. Is that
Yeah,
okay?
I agree. I think chat can help out, but um, help on who you want.
Oh yeah, you
Right.
can push forward who you want to win.
okay.
Okay.
Well, in that case, I think it might be good to show your browser too, or not as like a cheating, anti-cheating thing, but just a curiosity. I don't know, just just a
I
thought.
I have a browser that I have open, so that's fine. I have Dawn also open here, so well, but I'll have a browser window
Oh
so we can
yeah,
see what's going
and I
on.
can show mine too.
Okay, and then I think the way that I thought we could maybe start this, but put your own input in if you have a better idea, is that I'll just put the PDF for the first problem on Don's broadcast prompts. I'll just do it one problem at a time. And then I was thinking we could have the problem up and just discuss it verbally for a minute or two to go over, like, just to make sure the problem statement is clear. And then I'll hop off voice and you guys can start. Does that sound
Okay.
good?
Yeah, and we can use this
Yeah.
green room thing if you want. So like that way, you can just hang out there or wherever you feel comfortable.
Okay. Well, actually, I'll mute myself. How about that?
That's fine. That's fine. Um, Another thing. So because I haven't seen these, are they? Are these going to be singular answers, or are you going to be evaluating code? I just
Or
need to know.
just singular answers.
So
Yeah.
these will be
Uh,
some kind of rational or integer or something that has a very distinct, clear answer that we're not like being judged on code style here. It's just sort of get
yeah.
it done.
The former. The former.
Okay. All right.
Okay. So should I upload problem one to your Discord then?
When you're ready.
I think
And
so.
it's
Yeah.
Dawn's
Okay.
Discord.
No, I'm sorry.
Uh,
It's Zach's
Okay.
Discord.
That's fine. I don't care which. Like again, no problem. We're gonna see how this goes, chat.
Okay. It's posting now.
Cool.
Okay. So I'm watching Zach's stream right now. I can watch Don's too. But if either one of you pull it up, we can just talk over problem one, and then you guys can get
Let's
started.
do this. Okay. All right. Excited. Okay. So we want to read it together, I assume.
Sure.
Okay. I'll read this one, I guess. All right. So we've got a traveling salesman lives in a three-dimensional space with a vector being an R3, having an x, y, and z component with non-Euclidean distance metric given by the following. Okay. There are 100 cities in this space located at coordinates x, y, and z, k, labeled by integers k from 1 to 100. The one k equals one city is at the origin. This x1, y1, z1 equals 0. And the k bigger than one cities are located at these positions here. So we have some different expressions, mod 100. Your goal is to find the shortest path that visits at least 50 cities. You may start and end at any city of your choosing. And you need not start at the end and end at the same city. Whoever finds the shortest 50 city tour wins. So again, this is a distance that we're trying to find, yes?
Yeah, but I guess you should also show the cities too, just so
The
we
cities
can
tour.
we can
Okay.
verify. Yeah.
A path. Okay, so a path, and Jeff correctly here notes a path. Okay.
Yeah.
And so we have a distance metric. We have these Now, for
So
clarity,
more distinctly say it'd be a subset of the K, an ordered subset of the K. So like 2, 25, 7, something like that.
And so these are the locations, XK, YK, ZK
Right.
are at these locations.
Mhm.
Okay. Right? So the goal
Yeah.
is to find the shortest path that visits at least 50 distinct cities. You may start and end at any city of your choosing. You need not start and end at the same city. Whoever finds the shortest 50 city tour wins. Okay. I'm satisfied. Don, are you satisfied?
Yeah, I think I understand it too.
Okay.
Okay. I'll go on mute then.
Now,
Good luck.
one other thing before we start. How do you want us to alert you that we have a solution?
I'll be listening in chat
Okay.
on both channels.
Okay, so do you just want us to? Will you come in and verify, or do you want us to just sort of?
Well, so this
like-
problem, I don't have a solution to this. I don't have an exact. Whoever gets the lowest wins.
Whoever gets the lowest
Oh,
wins.
okay.
So sounds good. We're
Yeah.
going for lowest
I see.
score. Lowest score will get.
I don't know the exact optimum. I don't know.
Yeah,
But I do
whoever
like
gets
just
the better
finding a
solution.
shorter path. Sorry, what?
Whoever gets the
Right,
best
so-
solution in the shortest time. Okay.
So we should fix the time. And I thought 30 minutes seemed kind of short for this, but I don't know. However you guys feel.
30 could be fine. I don't know how Don you feel if we're going for a shortest.
I mean, so what's going to happen at the end of the 30 minutes? Like, if one person has an answer, the other doesn't, does that person win, or?
Yeah, whoever has the shortest at the end of the time period.
Yeah, I guess let's try for 30. And if me and Zach are both struggling, we can do a little, like, last minute extra time thing.
Okay.
I guess.
All right.
I do have one question now that I look at it more carefully. I see the definition for X, Y, and Z. Like, for X, it involves the last Z. Is that intentional? I just want to make sure, like, X and K.
That's intentional.
This is recursive on purpose. I want to make that.
It's like the X depends on the last Z value, not the last X value, like I initially thought.
Yeah, exactly.
Okay.
It's not a diagonal recursion, I guess you could say.
Okay. Cool. I'm good then.
All right. Do you want me here giving commentary or no? So you like I can mute myself.
I think you guys should definitely talk it out, but not audible to each other.
Okay.
Yes, I
So
have to
I'm
go on
gonna
mute unless I need to say
I'm gonna
something.
put you on. I'm gonna deafen you and turn off the mic here on Discord. But I'll stay in here in case I want to trash talk to you. So
okay.
okay.
Sounds good.
All right.
All right.
All right.
Well, good luck.
Let's start in 3, 2, 1. Let's do this thing.
All right. Okay. I hope I got this. And yeah, Milk, it's today. They're posted in Zach's Discord in the broadcast prompts. So I'm thinking I wonder if there's going to be a better way, but like, what's the immediate issue by going wherever we start, we just get the closest one, and then we go to the next closest one, and then we go to the next, like wherever we're currently at. Maybe there's like such a thing as a detour where we take a temporarily longer path to get a bunch of clusters closer together. But I really don't know how to analyze this recursive sequence or something that will be like that. I think that the first task, we should probably generate our coordinates. How the hell do I want to do this? So x equals np it's probably I'm gonna keep it as separate for now because I just I know how to work with things if they're separate. I don't know how to work with things if they're It's gonna get complicated for me mentally to track everything if it's in one array, I think. So Enigma, what we kind of agreed to is don't just like, you know, give us code that solves the entire thing for us, but we are allowed to like discuss the problem and like kind of nudge me along. So I guess it's a little bit like up to like our judgment, but it's not like strictly no backseating or anything. I shouldn't worry about this right now, right? This is I'm not going to deal with that text. Dijkstra's algorithm. Dijkstra's algorithm is probably a helpful thing here. I just don't remember it. I'm gonna do the immediate thing here of worrying about generating all these coordinates and then figure out the algorithm after. So our first coordinate is the origin, and then we're gonna go. So we already have the first coordinate. So we're gonna go. I mean, we can still make this range from 1 to 100 because that'll be 99 things, I think. Are gradient descent methods even? I don't know. Start a random search early. So that's a good idea. Let's just get an answer because of the way that we're doing this format. Like, just so I don't like run out of time. I only barely know how to code Megalomorph. Okay, so we're gonna say x cities dot append np dot pi squared times, I want parentheses here just to make sure the order of operation is gonna behave how I think it is. Let's not have a stupid mistake on the values that I'm generating. Plus, or wait, times the previous z subcities I minus 1. Plus np, is there np.e? Yes, np.e. And we want all of this mod 100. Some kill stream run 2 plus random searches. No, I did. Okay, good thing I cut and not just deleted. Recursive function to generate the coordinates and one to calculate the distances. Algorithm. Oh gosh, yeah. Part of the issue for me here is that I'm terrible with programming, and I'm probably gonna have to do things in a less than optimal way because I just need to do things in terms that I'm familiar with. For me to be able to get an answer here. In relatively short order. np dot square root 2. Okay, so I think this generates our values. NumPy arrays, they don't have dot append? I swear they do. Print x. I feel like I've used it before. Oh, okay. I guess you're right, Phobos. I shouldn't doubt you. Why would I doubt you on this? Make them non-numpyless. I could make them length 100 as well. I guess. Trade Python for money these days, you're in top form. X cities, I just have a feeling that NumPy might be helpful here, which is why I was trying to use it. But it might not actually be helpful. Wait, oh my god. Why am I... How do I get rid of this stupid bug? By the way, it's there from the last time I was coding. I don't know if this is expected or not. The first x value, we expect e mod 100, so that is e mod 100. So I'm going to assume this is flawless and not check any other values in my array. Do this with a Markov chain per chance. You can't just say per chance. Okay, so I'm going to assume we're generating our values correctly. Programmer's optimism. I checked a single value. I don't know what more I can possibly do here, you know? What do you expect of me? So, I almost want to... Is Desmos available to use? I guess so. I want to... Is chat... No, I mean, not that you can't just copy paste the question directly in if you want to ask, like, we're allowed to like Google for syntax or a relevant math concept. Well, I guess what I would need to do here is we want to cycle. Okay, so just in the spirit of getting an answer here, I kind of want to do the first thing that came to mind for me, which is just naively going from, naively always going to the closest point. I assume that's not the optimal way, but let's just get something here. Oh, and you're right. Yeah, okay. Let's just actually do that simpler thing, Milk, and let's go 0 to 50. And do what Milk said. Just get an answer here by going just from 0.0 to 0.50. D plus equals x. How do I want to do this? NP dot square root. Oh, wait. Oh my god. What the hell is this? It's the maximum. I didn't even like think about how we're actually defining this D value. It's the maximum. It's probably kind of equivalent to just, or it probably comes out to get you a similar thing as just getting the distance formula. Hey, Divya. But we should it almost looks like a Python function. Does this function hit? Oh no, that's gonna be like maximum for Yeah, there's np.maximum, but that wants, like, I need to make some kind of np object for it to get the maximum of. Yeah, I can definitely write that function. It's probably a good thing to do. But I'm wondering... I'm good, Divya. Oh, okay. Def DAB. Oh, but what am I going to pass into AB? Or what are AB going to be? I guess tuples? Or threeples? If, A0 minus B0 A1 minus B1 and there must be a better way to write it than this, but I'm doing it like this. Or, I mean, am I overthinking the np.maximum thing? Yeah, that's supposed to be... well, I mean, can't I could make an array of these. Frickin' hell. Yeah, with brackets. I was just trying to remember, like, how I would do that. Thank you. A0 minus B0. np.abs. Divya, I never really had to prepare for the JE before, so I don't really know what advice to give you there. I'm sorry. Print D X cities 0 Y cities 0 Z cities 0 comma. This is probably not good, but swim takes from 2 to 3 positional arguments, but 1 more given. Really? Oh, np.max. .144. That seems reasonable. Because pi is greater than e is greater than root 2. Okay, cool. Zero 50, because that gets us 0 through 49, which is 50 things. 15 minutes remaining? Oh god. Let's see if I can really get cooking here. Well, maybe we'll check in with Zach at like the 5-minute mark or something. For I in range 0 to 50. Hey, Waffle. D plus equal calculate D. X cities, Y cities, Z cities. Ah, wait, I. And I guess this is going to be I plus 1. No. Print D. Okay. Maybe I'll put this in chat just for record keeping. D. Okay. First answer from visiting cities 0 through. I'm good with that, Cook. Yeah. Okay, so we have an answer locked in here, but if that's the answer, that would be pretty surprising, you know? So, my next idea was to, well, we can just comment that out. Well, no, this is yeah, we'll comment that out. I guess we're always going to start with for I in range 0 to 50, because we want to do something 50 times to visit 50 cities. It's going to teach them random whiteboards. Yes, you know, Zach said that if I win, he's gonna throw his chalkboards in the trash and get whiteboards. And if I win, I don't have to do anything. Random.sample list range 150. Oh, for the random path? Is that going to be better than just the thing that I did with going 1 through 50? Or are you saying that maybe for something else? So I figure if I mean, might get something that's shorter. Um, oh wait, choose a city from the list to start. Remove it from the list, but calculate distance to all the remaining cities. This is the closest one. Remove this new city from the list. Oh, we need to ensure we're visiting distinct cities, otherwise we're going to go back and forth. I didn't even think about that. We need to track what cities we visited anyway for record keeping purposes. So we actually don't need this current city. Well, it'll make it a little bit easier. Maybe, let's just do a not numpy list, because I want to append on this thing and do the last index. So, I mean, we're guaranteed to start at city 0, so we want to start from 1. So we need to calculate the distance to every other city. For j in range 0, np.size of cities. I should have like gotten a timer to track this too on screen, but oh well. Dave, yeah, right now I'm not taking questions, but if it's either in YouTube chat or in the Discord, if those don't work, then it's hard for me to help. Distances. Distance dot and calculate the cities. So we're using I here. Oh no, we do want to start from 0. No, we don't want to start from 0. Yes, we do. Visited cities. X cities of visited cities -1, I think is what I wanted to do. This is, a lot. Can this thing get out of my face? Thank you. I guess that's the first tuple that I'm passing in. So then I come here. X cities J. Y cities J.
Hey guys, I just wanted to check in. We got about 4 minutes remaining.
Cool. I'm almost ready to run this. So
Well, do we want to agree to adding 15 minutes, maybe a little more, or what do we want to do here?
I'm okay with that if Dawn is, unless you don't want it, Dawn.
I could use some extra time here.
15 minutes it is.
15? Okay, I'll add 15.
15 it is.
Okay. So we have about 19 remaining.
Okay. And then I have a like an initial answer that I put in my just like Twitch chat and how I got it, just a heads up. I'm still like working more on it. Okay.
How will we put the final answer on the broadcast prompt on Zach's where I put the question?
Sure.
Sounds good.
But yeah, okay, see ya.
Yep.
Okay. So we've now gotten the distances of all min equals. Now, does this, is this going to get me some min of distances? Visited cities dot append distances dot index. Ooh, and shall be index of returns first index of value. Oh, no, no, no. This isn't going to work exactly how I want it to work. Because I care about which city it is, not... Or I need to track which city. I also need to add. So what am I doing with this array here? I'm going over the entire array regardless of whether I've already visited it, which probably isn't good. We can say if J not in visited cities. But we need some kind of filler there. Then we do this. Else there must be a concept for the maximum integer in Python, right? Really? We'll just make it something stupidly big. Distances dot append 10 star star 20. That seems ridiculously big. And that way, this is pretty cheesy. But whatever we're putting here for like, city 0 should be so stupidly big that it'll never get caught in this min, is my hope. Visited cities that append, and then we also need to track the total distance traveled. D plus equal distance is min. Is this going to get us something? Print D, print visited cities. Oh, I don't, just the bracket. Why does I have an extra bracket? It still doesn't like my call to calculate D. This code is impossible to read, to be fair. I really am not doing myself any favors with this. Why doesn't it like about this? 2 positional arguments, but 3 were given? Oh, I didn't make that a tuple. Doi. Okay. Any repeats? That's a lot smaller than my... Why am I... Oh, I'm printing D twice. That's what was confusing me. Okay, so there are 50 things in that list. And I want to ensure there's no duplicates here. Good, no duplicates. Okay, so we've gotten down to 599 from doing always the closest one. Choose a different... I mean, I think we have to start from zero, from the origin, don't we? Oh, no, you're right. We don't. I don't know why I assumed that. Okay, yeah, you're absolutely right, Milk. We need to... get another for loop in this, I guess. Just 3 levels. Yeah, I'm sure there's not a better way to do this either. I'm sure this is best. I do have to reset D. You're right. D equals 0. I mean, I can keep that there. It doesn't matter. But we do need to have like a tracker for Mindy and min visited cities. Sure. And then at the end of this loop, if D is less than min D, then we want to keep those. So we're going to set min D equal D and min visited cities equal to visited cities. And then down here, we're going to do min D, min visited cities. Min visited cities, just for our sanity checks. Min visited cities. Okay. What does that get us? Signal. Oh, that's not good. If D is less than min D. Oh, well. Well, there's your problem. We got 0 distance. We're gonna win this for sure. Oh, we should make sure it's a deep copy, right, Milk? I don't know. Python list deep copy. Copy.d copy? List? Okay. Visited cities. I completely forgot all that, Milk. Good point. Oh, I might have happened to get us the same output anyway. 50 distance? Really? Wait, no. 599 distance. Really? That's just 599.0199. That seems weird. Why is it the exact same as when I started from the origin? Does it happen to be that the origin is the best one? 9 minutes? Okay. Wait, I'm resetting this every time. I should not be resetting it every time, right? Well, there's your problem. I still get the same thing. Hoo-hoo, hey. How are you doing? How do I get the same thing? I tried starting at C. Oh, I'm not actually using my C. Yeah, that's a good point, Phobos. God damn it. I'm doing good. How about you? Visited cities hasn't started. Okay, there we go. I just need to update that 0 there, and then maybe we're good. Visited. I tried starting at C. You're very right, Phobos. X. Wait, visited cities. Yeah, we just make that a C. $542. That's a different answer. Okay, good. There'd be no confusion. This is an R. Oh God, I've written like probably I would bet like 30 lines of code in R total. Hope you're doing well today. Hoo hoo. I don't know, like, so from here, I don't have a better an idea to improve this, especially with less than 9 minutes left. What if I shuffle them? What would that do for me? Be a little tricky, but might be fun. Like, just choose the order, or give you all 100 starting cities? Yeah, I just realized we should do a sanity check up here. Make sure these are all 100. Okay, good. Give you all 100 starting cities. I guess I don't know what you mean with that, Phobos. Okay. I think I'm ready to lock in. Because I don't have an idea for improvements here. I feel like 542 is not a bad number. Um, and then I guess we'll just be hanging on until Zach is done. There probably is some algorithm that can do this better, but I doubt I can implement it in the next like couple of minutes. Territar says, have you tried using itertools.permutations? How would that help, Territar? No, starting from the origin, we got 599. 4 minutes left? Okay. Doing every starting city, we found 87 is the best starting city with 542. Lost my whole permutation groups ran out of time. You have a list describing the order of cities, and you want to optimize that list. Yes, Cook. I have that ready to go, so I'll put in Zach's Discord in a minute or two, depending on if we have some sudden last-minute realization. Oh, interesting, Territar. And so, well, ooh. Yeah, so getting every like permutation of visiting the cities might be a helpful thing. That'd be a lot of computations, though. Actually, I mean, that would definitely get the exact minimum, though. Yeah, to brute force it, Territar is saying to... I guess we'd have to get... There'd be... we have 100 things. We have to choose 50 of them. So there's going to be quite a few of those. That's going to take longer than I have to implement, but that is an interesting way to go about it. Okay, I'm going to go ahead and post my answer in Zach's Discord here. All right, post my answer in the Discord. 100 dimensional problem, brute force is a bad idea. Oh, okay. I would have to like find out the hard way. Have you guys set a limit for how long the program can run? Just the like kind of global 45-minute time limit. Run the A-star algorithm. Starting at each individual city, we don't have enough time to implement it. I never heard of the A-star algorithm. I guess we have a little bit of time. Apparently I've looked at it before because that link is purple. We know this is a goal node, I guess, but I don't know. You're probably right. A-star has improved Dijkstra's. Oh, okay. Should I wasn't playing
Okay,
music.
I think Zach is putting in a final answer.
Okay.
Yeah, I'm satisfied with mine. That's as good as I can get.
Satisfied with mine too. I'm gonna look at Zach's answer.
Okay, so Don is claiming a shorter distance.
Holy crap!
Oh, really?
Wow.
Oh, wow,
So
by a
I
lot.
try,
Huh.
I spent the last few minutes trying to write this up myself, but I realized there's a bug. So I was hoping I could check this, but maybe it would be good for Zach to see if Don's sequence actually has that distance in his code as well.
Then that's and
Five.
vice versa. I would hope that you can.
Yeah,
do the
Yeah.
same.
yeah, that'd be a good check to do.
Okay, so I should be able to run. Let's put yours in. Okay, let's write a quick function to make that happen. So
Can I get you to copy paste the text of that to me, Zach? Though it's a
sorry,
little hard to write in.
yeah, I can do that. I wasn't thinking about.
Yeah, I didn't predict this either.
Yeah, I didn't know what we were going to be getting, so I was just trying to get a low number. Oops, that's yours. I was using that. I'm just going to put this in a safe spot. All right, so now let's give you that in text. I was just going for time to try and get
There we
the.
go.
That's it. And Enigma in your chat is saying stuff about A star. I think that's a good way to do it. If I had had like time, just do a search, find replaced on.
Oh my, you're right, Zach. Thank you.
Find replaced. That'll save you a little time.
What about the hard way? It's so much
Why do
better.
it the hard way? So let's see here. If I give I didn't write a function for this, and I probably should have. Okay, so we'll just take this thing. Path equals path distance
And Zach, is your array going 0 to 99 or 1 to 100?
Let's see here. How did I do it? I did it from 1 to 100. So you want to subtract 1 from those.
Mine's 0 to 99.
Okay. So good to know. I don't need the -1. That was an error I was getting earlier. So here's the hoping this works out. Okay, so Don's distance, path distance to 2s. Let's see what we got. I shouldn't have put it on so high. Mine comes back 542.38. I think you're the winner here.
Oh,
that does tell me consistently. I will yield to Don here.
Okay.
Nice.
I hadn't quite gotten to check yours, but if it's
no, congratulations. I'll cede you the victory here.
Awesome.
Okay. So do we want to do problem number 2 then?
Yeah. I mean, good job. Well done.
Okay. I'll put that in the chat.
So just Enigma wants to know how we calculated coordinates. I just sort of did it by raw calculation. Nothing fancy. I suppose I can put.
Like, how did you make your choice though for what city to go to?
I just did it random. Like, I didn't have any preference. There's probably better ways to do that, but I chose to just sort of do things randomly and take the best thing I could get at the time. So
That's fair.
I probably could have done better had I started more strategically, but I was getting 2000s at first, and then I got down to 1800, and yeah, we didn't get much. 1800 was something. I think it was like 1827 is the smallest I got, just by random chance.
Okay, and then I always took the closest city from wherever I was at.
Okay,
Yeah.
that's reasonable. That's probably better.
But all right, I guess we're ready for round 2.
Round 2, yeah, well done. Okay, so that got me
Okay.
into it.
All
Well
right.
done.
I'll put round 2. So this one isn't of the kind whoever gets the lowest win. This has like a definite answer or non-answer. So
Okay,
maybe 30 minutes. We'll start with 30 minutes and go from there.
Sure.
yeah, sure.
Okay,
Sounds good.
I put the problem statement in. Let's talk about it, make sure it's clear.
Okay, Don, you want to take this one? Read it.
Yeah, I'm just bringing it up. 1 minute. Okay. The vinaigrette cipher, I'm going to pronounce it, is a method of encrypting plain text in which each letter of the plain text is encoded by shifting it alphabetically, with the increment determined by the corresponding letter of another text, the keyword. Huh. Okay. For example, consider the vinaigrette cipher with the keyword ABD.
Vinaigrette. I'm going to use that. The vinaigrette cipher.
I don't know how to pronounce that.
In my head, I always say visionnaire, but I don't speak French, so that's probably wrong.
That's probably pretty close, actually. Visionnaire. That looks right.
Maybe
vinaigrette is good enough for me.
Which encodes the plain text into ciphertext by incrementing the first letter of the plain text by A equals 0, the second letter by B equals 1, the third letter by D equals 3. Oh, okay. The fourth letter by A equals 0, fifth letter by A equals B, sixth letter by D equals 3, and so on. So it's like an advanced Caesar cipher, where it's not always the same shift.
It's a shifting Caesar cipher. Right.
Okay. With this cipher, the plaintext "a lazy dog" becomes a lazy dog. We remove all the punctuation and spaces from the plaintext. We would then encode it to have the ciphertext AMDZZGOH. The ciphertext below has been encoded using a visionnaire cipher with an unspecified keyword applied to some plaintext. After the space and punctuation have been removed, find the keyword and decrypt the below ciphertext back into the original plaintext. Okay.
Nice. I love it.
Huh.
So this would be a more creative one, I thought.
Yeah,
you guys ready?
It's gonna be interesting.
I like this.
All right. We'll start with 30 minutes.
Okay. Very good.
All right.
Very good.
So the problem statement's all clear. No questions.
No questions right now. Yeah,
I'm good.
I think
yeah.
I'm okay. I think I get it. It's one. I guess one thing before we go. Hold on. The D equals 3. Is that a typo or no?
No, it's C would be 2 and D would be 3. So A does nothing.
Okay. A does
so
nothing.
If you look at a lazy dog, if you look at a lazy dog, the first key letter A doesn't change that at all. So the ciphertext in the example also starts with A.
So the Z would move 25 spaces.
Yeah, exactly. So Z would take Z to Y.
Uh-huh.
Is that true?
I'm trying to make sure that I understand what this is. Plain text a lazy dog. If you use this cipher, I'm good with the thing, but sorry, I thought lazy dog was the cipher. Sorry, the lazy dog is the plain text. So every third letter doesn't change. Right.
Exactly.
Like the first one and the fourth one and the seventh one don't change, and that checks out. Okay.
Yeah.
Okay.
Exactly.
Yeah. All right. Fair enough.
A question from Milk is we don't know anything about this keyword, right? Nothing about its length or
No,
anything like that.
you're not told anything about its length. The only thing you're told it's purely alphabetical, like A through Z. It's a
Okay.
string of letters A through Z, but the length is not told to you. No.
Okay.
All right.
All right. Cool. Good
Very
luck.
good.
I'll start the timer. 30 minutes.
Okay, very
All
good.
right. Good luck.
See ya.
Yep, I'll see you in a bit.
Okay. Sorry, Matt, it's a little bit too easy for me to address your questions.
Yeah.
I'm competing against eToThe2iPi. He streams on Twitch, and the person who's kind of giving the problems and answering our questions is Dr. Cook, who's also over on Twitch. And that's the path I got Terratar. I've written code in Java, C++, Python, MATLAB, a smattering of other things, but those are the biggest ones. Yeah, so this one, I really love this idea for a question, but it seems really hard to crack a Caesar cipher with an irregular offset. Like, how do we even begin here? Ciphertext is continuous. Oh yeah, Phobos. We could try a constant offset and see if we get anything intelligible. I don't know if that'll actually like help all that much, but it might do something for us. And these PDFs are all posted over in Zach's Discord and broadcast problems for anyone who's just like joining late. Hey Ash, over on YouTube. It's gonna be a little bit hard for me to address questions quickly for now because I'm having a little like for fun coding competition. So there's gonna be a lot of times where I have to like focus on the coding. But welcome in. The theme of the stream is normally like math help. This is a little like special event that we're doing today though. No, Terratar, that would be a little too much, just getting a decryption library. Find repeating sequences, calculate the distances between them. Really? Repeating sequences? I wonder what that would do. So we each have a keyword of like D. What would that do for us? Oh, how do we... Oh man, Python might not be a good one for this. It's like we want to split this. Ash, it's gonna be a little bit too much to explain this problem. Like we're on a timer here and I'm competing against Zach, so I'm sorry, because I can explain it after, but trying to go back through and like explain it well, it's going to take a little more time than I have right now. I'm sorry about that though. Python split string into characters. We're going to need to list. Okay. Thanks for understanding, Ash. See, okay, this person is saying not to do that, but like, let's be a rule breaker, I guess. Encrypted cars equals list encrypted. What? Encrypted. Really? Oh, I don't know how to spell encrypted. That's the issue. A string is already a list of cars, but it's not mutable though, I guess, is maybe the issue. Or I assume it's immutable. I want to be able to subtract my offset. So I guess let's just see if this has an effect. Actually, I should do print if I do y, like, does Python know what to do with it, or what's the Python do with that? It doesn't like that. And I think this is the same thing in Python. It's not like Java. Okay. So actually, okay, so what if I probably need to do the int casting. Int y. Actually, let's just do that. Oh my god. Board? Oh, there we go. Thank you, Bubbles. Megalomorph. Yeah, you're allowed to like brainstorm. The only thing we don't want is like, you know, don't just like give me code to, or like don't give me like the entire thing to just like copy and paste in, or like don't like completely give it away, but like nudges are fine or brainstorming is fine. Having a specified length has length much shorter than, okay. Good to know, Cook. Does lowercase a really start ASCII values at 97? 96, okay. Oh yeah, wait, 98. Yeah, 98. So we want to subtract 97. Like that is going to get us things. Yeah, so B should be 1 here. So maybe we should make car to int and then int to car. Return, okay, so I'm given a character and I want an integer back. So return ord C minus ASCII offset. Def int to car I. Now how do I convert integer to character? CHR? That seems like a good guess. I plus ASCII offset for the thing that I'm doing here. Now let's test this. Car to int B, print int to car. One and B. Okay, good. These functions I think behave how I want them to. C2I and I2C, they are fun names. They are a lot shorter too. All right. C2I, I2C. And Davis, look at, let's say 20 most common English words, and then for each snippet of encoded text, they will be required of the code word if the snippet decodes to that common word. Oh, yeah, like the. Code would have to be. The frequency thing, I think Megalomorph said earlier that, or that it might not work if with this not a constant offset though. Or you wouldn't get the same thing. That frequency analysis. Try most common English words. Try all the offsets. It's really weird that we get some actual words inside this too. Seed. 20 minutes remaining. Oh, geez. So, like, okay, let's just. C2I of C plus I2C. Well, this is really gonna. Well, let's just hard code that to be a D, because actually working with this keyword is going to be a separate issue to implement that. And so we want I to C this entire thing. Wait. C to I to C. I think like this. Add the character, add the offset, convert it back to a character. Print str decrypted. Descripted? Decrypted. Oh. Lasting 16 years ago, I find string-based problems easier than others. Oh, interesting. How do I, join? Okay. I can't spell decrypted. I should just use tab. I'm in an ID. Oh, I get some special characters. So that could... The existing special characters could... We know it's not going to be a special character. That forces keywords to be in a certain range, right? Oh, do I have to mod it? Really? I guess I should. Yeah. I mean... The first letter... Yeah, you're right. I did do it wrong. Character to integer. So we want to mod this 26. But if we're doing it 0 to 25, does mod 26 work? Zero is still 0 mod 26, I hope. I feel like... Wait, we should, we need to do some testing here. Do we want to mod 25 or mod? So we want to convert, say the letter B plus 27, which we expect to get us C, right? Ugh. Bracket. Um, we mod that 26. Do we need to mod these both 26? Character to integer. We probably want to mod them both 26, I guess, right? Space or tab or something? Do we mod them 25? Wait, no, I'm doing this wrong. C. Okay. Guess and check always works 100% of the time. Do we say that to be the same as adding 4 to B, C, D, E, F? Okay. That's what we could, yeah, okay. I don't know. I don't know what I was hoping. Um... Oh man, we could get every. Oh, maybe what I was saying is was to get every offset. Is there a way to like parse through them all and stitch together a sentence that makes sense? That seems kind of hard. Hmm. I'm still not sure exactly how to attack this, but we can at least do something that's still helpful and make a decrypt function, I think. Um, character frequency, not word frequency, but the character frequency approach seems tricky when. Oh. If we got every offset possible, put them all in one mega string, and then did the character frequency, should the most frequent one likely be E then? Maybe? I'm trying to figure out how to use mod to step through my keyword appropriately. So I think we need C to be an actual number here. And I think Phobos, the answer is yes, if we're thinking the same thing. So we need to convert C to I of C. I think so, Cook. I still don't know. I still don't have a good idea for the actual algorithm here, so I'm down for a time extension. Key times equals 1,000. No bounds to worry about. I don't know what that does for us. I assume it's an actual message. Or the keyword, I'm not sure, actually. No mods to calculate. Oh, does it duplicate itself? Oh, that's what you're doing. If you multiply a string, it concatenates itself a bunch of times. And you can just... Dang it, that's so clever, Phobos. Yeah, it probably is. Yeah, that's a good point. $10.
Hey,
Hey.
Hey,
hey, I just wanted to check in. We're about 8 minutes left, and I want to suggest that we do an extension of 15 minutes again. And I also want to share that the keyword is not a totally random sequence of letters. It's
Okay.
a human intelligible string of text.
okay.
Good to know.
So are we down for the 15-minute extension? Well, does that make sense?
I yeah, I mean I'm running on a tight schedule today, so I'm hesitant to extend further on this one.
Okay.
But I don't know, Don. How do you feel?
For schedule reasons, we can just keep it shorter. I'm not particularly close to a solution right now, so if you are, then like you might just take the win anyway here.
Well, I don't know. Like I think let's extend this one, but I want to sort of evaluate time because I do have well let's keep going. Extend for 15 minutes. That's fine. But let's talk in
Okay.
15 minutes about time. Okay.
Okay, so we have 7 minutes to go. I'll just increase it to 20. How about that?
Great.
Okay.
Sounds great. Thank you.
Okay.
Okay, we'll
All
see you in a bit.
20 minutes.
So what am I doing here? I'm converting message of C to an integer. I am adding the key and I'm taking this entire thing and converting it back to a character. It's kind of hard to check this. I could do a simpler encrypted keyword. Ah. So just as a little... Dude, why can't I spell decrypt? I think I've spelled it right once on the first try. The shorting. Oh, true. I should use that. A lazy dog. A B. Oh. I'm gonna only give my code lowercase text. Yeah. Oh, that's gonna be a problem. Well, what am I returning? Oh, I'm not returning anything. That seems like a problem. Decrypt almost... It does, yeah. AMDZZGOH. Good, okay. Decrypt is where I put coffins. Ugh. Oh my... Wait. I encrypted it. What the hell? Wait, what? What did I do? I encrypted it. You're right, Phobos. Let's just change the name. I need to decrypt. Oh my god, I'm so... Ugh. I just need to do the same thing, but I subtract. I think that's the only difference. AMDZZGOH ABD. Okay, good. I wrote decrypt inverse. Yeah. Okay, so I don't know what I'm actually going to do here. So the idea that I guess I thought I had was getting every single word keyword, putting them into one mega string, and then doing the character frequency analysis, because that should hopefully let me figure out the most frequent letter? Encode and decode? Too late. 15 minutes? Okay. I mean, it's really not too late at all. Okay, fine. Encode. Decode. That way I can spell it right. Sure. All the questions are posted on Zach's Discord in broadcast prompts. What is this? Is this going to work? Ah. Really? Matplotlib is plot. Oh, .pyplot. Ugh. Why doesn't that just get all matplotlib, including pyplot? This is just a blank figure. Um... What if I make NumPy have to deal with making this thing into an array that hist can deal with? Ugh. Length of unsized object? Like, it is a mega string. 10 minutes? Oh god. Hmm. Not that. It's making the buckets too big. Bins equals... It's one giant block. It's literally just a blue square. But yeah, I definitely... This was just trying to get every single offset and then trying to do like that character analysis thing. So I feel like I don't know how else you would make a character analysis work if you're not getting every single offset. This would be a neat one to see what Penn Center thinks of it, because I know he teaches a class that like talks about some encryption stuff. But like that would probably be random. Um, right. I guess so. I'm just kind of stuck though. Like I don't know how to begin actually cracking this. Five minutes? Oh, geez. Can I find? Is there a way you can figure out what the length of the keyword is somehow? Like, can we try to figure out a pattern by looking at the string in pairs versus in trios versus in quadruplets? Like, is there something we can dig into there? So like right here, we have 5 V's in a row. I can't think of a single word in the English language that has 5 characters in a row. So I think we know that our keyword has to be less than 5 characters. Yeah, PhD, I think we're on a similar wavelength here. Uh, So yeah, if we guess a keyword length, one of the earlier general attacks on the cipher, we know that every, like, based off that 5 V's in a row thing, I feel like it should be like 3 or so in length, the keyword, like something pretty dang short. Which I guess Cook said that it's short relative to the length of the message. So if we instead got every third character, I guess. What? Well, we're not going to decrypt anything quite yet. And this is step size? So we step by 3? Int object is not iterable. Well, oh my god. I didn't mean to. I hit something that I didn't mean to hit. Okay. So we get this. So there's a whole lot of B. So does every third B potentially get mapped to be E? Like, is that what conclusion we would draw here? So we would try I would suspect that the first character.
Hey, Zach,
Hey.
Don, are you guys there?
I'm here. I guess Zach is still.
Okay, well, the time ran out, but I have a proposal that we could maybe do to resolve this one, if you guys would be open to it.
I mean, yeah, but is Zach at his stream? Or did he like get up?
He's on stream. I don't know why. Maybe he's not hearing us somehow.
I'm here. Yes.
Oh,
I'm
okay.
here. It's unmuted
Oh.
on Discord. Okay. What's up?
Okay, so I think I have a suggestion to resolve this one. I could verbally say the keyword, and then whoever puts the plain text, the decrypted plain text first into that broadcast prompts problems wins the round. How about that?
Why not?
I guess so, sure.
Okay, so the keyword is no spaces, Kiev, Ukraine.
How's Kiev spelled? I think there's multiple.
That's true.
Kiev. Kiev,
Okay.
Ukraine.
No. Wait. So I got.
Oh no.
Wait, that's not it. No, 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 no.
What is my VS Code doing?
I think Zach has a bug. He
No.
hasn't
Oh
quite
wait.
got it.
Mine is too long. I got or AutoMod held it up because it's spam.
Oh yeah, I think Don's got it. I see on stream. It's not letting you paste it though.
I'll show my Discord.
I see that. I see you got it on the stream there.
Yeah,
Uh,
the AutoMod thinks it's spam, but I always tried.
Yeah, I think Zach had a bug in his decryptor because
Oh no.
when he put the like it started off right, but then something went off track. You could maybe put a
Yeah, Zach's is
screenshot
like
into
truncated.
Discord.
Oh, screenshot. Yeah, I'll try that.
So this is an Einstein quote. Um, maybe one of you guys want to read it before I put the next problem up. And also, I think Zach still wanted to discuss time.
Okay. Often in evolutionary processes, a species must adapt to new conditions in order to survive today. Or in order to survive. Today, the atomic bomb has altered profoundly the nature of the world as we knew it, and the human race consequently finds itself in a new habitat to which it must adapt its thinking in the light. This is really hard without spaces or punctuation. In the light of new knowledge, a
So
world
it's
for
Einstein
the
too. He's not the easiest even with spaces.
true and an eventual world state are not just what worlds and an eventual world state are not just desirable in the name of brotherhood. They are necessary for survival in previous ages. A nation's life and culture could be protected to some extent by the growth of armies in national competition. Today, we must abandon competition and secure cooperation. This must be the central fact in all our considerations of international affairs. Otherwise, we face certain disaster. Past thinking and methods did not prevent world wars. Okay. Nice.
Yeah, nice man. All right, sorry Zach, you're 0 for 2. Maybe get some redemption on problem 3. Are you ready to move on here?
And Zach, if you really have to go, like, I don't mind trying to revisit this another day. I don't want you to feel like you really have to like be here, but This is a histogram that I got every third
You
character.
may have us muted
I was
again.
evidently way off
Or maybe
in
he
my
has
guess of
himself
the
muted.
keyword length.
I'm good. Okay, we're good now. Sorry. The thing here is that when I ran my code, it dies after exactly 8 iterations of Kiev, Ukraine.
Oh,
I don't know why. Like, there's no indication that should happen. And I might post the code if anybody wants to try and troubleshoot this. I'm super, like, I'm more angry because this was like, I don't see any
Your search-
reason this should fail.
Your search for the dictionary might have worked if that weren't bugs. Maybe you would have got it.
Maybe. Well, but Kiev, Ukraine wouldn't have been in that dictionary.
Oh, really? Okay, fair enough.
No, that dictionary just came with Ubuntu. That's what I was doing, Don, is I was trying to use a dictionary with all these different keywords. Kiev, Ukraine
that's
would
smart.
not have come up.
I was trying to do some character analysis stuff, but it's really hard with a non-constant offset.
Yeah. Well, but what's interesting is the original, the plain and cipher work fine. And so with the larger case, it just didn't work. And I don't know how I would have known that without doing more
Well,
testing.
as was mentioned in the chat, Wikipedia page for the Visionary cipher is really interesting. This was cracked, I think, in the late 1700s, early 1800s.
Mm-hmm.
So I think first guy was this guy Kosasny or something, but then Charles Babbage independently cracked it a little bit later.
Okay. Interesting.
It's a really cool problem. I want to look into it more after this.
I do too. I feel like I should know more about it.
In Western Europe, they thought it was uncrackable for like 100 years. So yeah, it's a step up from the Caesar cipher for sure.
Well, this is so. I took a class in cryptography, and I vaguely remember a table like the one I'm showing on my screen. This is from the Wikipedia, the tabula recta. I've seen stuff like this before, where you have diagonals that all have the same letter. This looks like it could have been helpful. Okay.
Yeah, exactly. Yeah, true. Are we ready for problem 3?
Let's do it. I'll post the code for both of these too. So if you want to like play with these.
Okay, so Zach, I know you're running low on time. This problem 3, the nature of the answer is whoever gets the lowest wins. You don't have to find the global optimum or anything like that.
No, it's fine.
So maybe we can do a hard 30 minutes for this.
That's fine. Hard 30 minutes.
Okay.
Let's do it. Home.
Okay, I'm posting it now, and then maybe I guess Zach, it's your turn to read, and we can just talk about it if there's any questions.
1 second. Oops. Looking for my code folder. There it is. I'm gonna post my code to here just so you can see it. And if anybody wants to play with my code and see what's going on with prompt 2 especially, I'm sort of interested. So the decipher thing I feel like should work. Anyway, this was a pretty cool problem, though. I like it.
I'm glad you liked it. Yeah, I thought a decryption would be kind of fun. And
Yeah,
Visionary, it's kind of like it's a little hard for the time constraint, but there's not really anything I know that's between that and Caesar, which would have been way too easy for you guys because you just got to check 26 things, right?
Yeah.
Right.
So
all right. Here's prompt 3. So let's continue. Place a digit in each of the 25 spots in the 5x5 grid so that each 5-digit number, leading 0, 0k, reading across and down, is divisible by the number outside the grid, trying to maximize the sum of the 25 numbers you enter. Whoever achieves the highest valid sum wins. So an example of a completed grid with sum 100 is presented above. Submit your answers in ordered pair of your sum and your 25 numbers, reading left to right, top to bottom. The example grid would be submitted as the following. Okay, so that took me a bit. Let me read that again more carefully now. Each reading across and down is divisible by the outside number of the number outside the grid.
So the first column is a number that's divisible by 6, for example.
Well, what about the 5 is indivisible by 6 or 2? Am I misreading it? The 5 in the second row I'm looking at.
The 5 in the second row.
Like
But it
in the
ends in a
first
0,
column.
so it's
Oh, the
you have to
entire
read it
number?
as
Oh.
you read it as one string of numbers.
So
Yeah.
16,235. That really okay. So then and then 52,460, 4,893, etc., etc.
Right. And leading zeros are okay. But they're
Alright.
bad for the sum you're trying to maximize.
So wait,
And
so
the
Sorry.
sum of the digits in the list here. Sorry.
that 5 in the second row, would we include the one that's above it when evaluating that 6 divisibility? Or is it 5,024 or 15,024?
That first column read as 15024 should be divisible by 6.
Okay, so okay.
Yeah.
I understand now. Sorry, Zach. Go on.
Is I'm checking that mentally, but it is. Okay. So an example of your completed grid with so the sum of 100 is the sum of all the numbers in here.
Should be.
So 1, 6, 2, 3, 5, etc., all added together should be 100.
Should be.
Hmm.
Or said another way, the second element of that list, if you sum all the digits, should be 100.
Okay.
Okay.
All right. Reasonable.
All right.
30
I'll
minutes.
start the
Let's do
timer.
it.
30 minutes. All right. Good luck.
Yep, thank you. Okay, this is
All right.
another cool one. Okay, I'll tell Zach to mute so he doesn't say anything aloud. So that isn't perfect, isn't it? My webcam was slightly blocking. Okay. I'm wondering, could we do like if I started with all 9s in this grid, could I iteratively edit it until like just subtract 1 each time from, I mean, that would be really hard though. Um, each 5-digit number. Start with all 9s. That's what I was. Yeah, like that's kind of. I'm just not quite sure how that editing process is going to work. It's like we can get a 5x5 grid. We can get like we can get that like this stuff here. Stability rules multiple 9. Yeah, like we do have some constraints. Like this lower right, it just forces us to be a 0, isn't it? Because it has to be divisible by 10. So we have a constraint on the bottom right corner off the bat. Wait, yeah. That means that this bottom row can, like, the 5 doesn't really add a unique constraint here, I don't think. Um, the divisibility rule is probably a good idea. I just don't know. I feel like the logistics of this are it's kind of hard because we can't just. Besides that 0 on the bottom right, you can't really set a number and forget it, I feel like. Like if I were to edit this 3 here to make sure the digits sum to 9, what if I find out later above in this column I need to change one of the digits? That would affect that 3 there. The 2 only affects 1 square, right? The 4 only affects 2 squares. Yeah, okay. Oh, okay, yeah. This is, maybe you can do all this by hand. Maybe I'm trying to think too much in terms of like iterations. Uh, 2 only affects 1 square. So like 1 comma 4 must be 2, 4, 6, 8, 0. I guess I'm also doing this like a Sudoku right now. 0 through 4, comma 3 sum to 9 or multiple. All right, so sum to multiple of 9. Yeah. And so the rule for 8, divisibility by 8 rule. The last 3 numbers are 0 or divisible by 8. Okay. Hmm. 2 through 4, comma 2, a multiple of 8. That's a number. Yeah, Femlux, this one reminds me of, like, it seems like a problem that you would like. Divisibility by 4. I guess, I assume it's the same thing as 8, just the last 2 digits. Yeah. Which means 3 comma 3 through 4. That's a number, or a multiple of 4. So yeah, I mean, if we figure out what things have to be, everything else can be 9, right? That's what we're going for with this. Is there a rule for divisibility by 7? Remove the last digit of the number, double it, then subtract it from the remaining number? The hell? How about 6? Well, okay. 6 will divide any number whose digits sum to a multiple of 3? Wait, really? Even number. Oh, okay. Yeah. So it's the 2 rules combined. So, 0, well, 0 through 4, comma 0, sum to a multiple of 3, and is even. It's a better one than is a good rule for divisibility by 7. So far so good, Eldritch. I'm up 2-0. I think this one is easier just tested manually. Like, I don't know how you would... I don't know how to make something helpful with that. $20? Okay. Well, we should get a dumb answer first, right? Just so we can have something that we can claim. Well, system of 10 modular equations. Do it all, system of 10 modular equations. Yeah. I never done a system of modular equations before. I wondered, I don't know how much that'll be either. I almost want to do this by hand for a first pass. So this is forced to be 0. For the even ones, let's try and get the best possible scenario here. Eight goes into 1,000, which means 8 also goes into 992. And for the 7, ugh. Wolfram, save me. So we need to subtract 4 off the end here. 4. Why did I make that a 2? Oh, because the 7 goes over here. Or the 5 goes over here. 9 plus 9 plus 9 plus 8 is 44. Non-multiple of 3. 42, that's a multiple of 3. So I think all the column conditions are met, is my claim. All the row conditions, the last row condition is met. 4 is not met. So let's bump that down to 6, and then we're good. 3, that's met. 2, that's... Wait, did I just solve it? No way. There's no way I got this right. One 6. 4 9s and a 6. That 4 was good? I don't know what 4 that was anymore, Ben Bucks. The 8? Oh, this? 4 doesn't go into 98 though. We can check it. No, it needs to be a 6. Yeah. If that's one you meant right there. Oh, wait. Yeah. I don't know. So wait, I checked the first column, checked the second column. Okay, no worries, Inbox. Second column's good. Third column. Good. Fourth column is by 9. Well, I mean, I should be able to look at that and know, but be real. 10th column is good. The last row is good. Second to last row. I already checked, but let's check it again. Good. Then we do by 3. Good. Okay, I think I'm good. Well, what's the sum of this thing? What did I just hit? Do I have to do a double sum? Sum. 198. That seems... Is that okay? Okay. It was by hand, yeah. So we have 198. Ugh. I feel like I'm optimal here. Why? Oh. But, oh wait, what am I doing? How do I print and not new line? I'm also trying to like format this. Okay, thank you, Phobos. Okay. So I'm pretty confident that you just can't do better than this, but like maybe we should keep on thinking about it. I mean, how can you possibly do better though? Hmm. I don't have the optimal solution? Okay. Can we shift this? I assume the last row is the... Is it the problem? It's a pretty... It's a pretty good solution, I think. Let's see if we can... True. I saw that Zach submitted an answer. I assume just to get something in, and mine is doing. My answer has a lot higher sum than he got. Well, just to be clear, oh, Zach just okay. I put mine in spoiler. He also put it in spoiler. I don't know. I'll just. I shouldn't worry about it. So. How can we do better here? Huh. The 2 hertz. But yeah, but we just... Oh. We get more mileage if this is an 8. And that is a... Is 992 minus 8. 6. No. 4. Second time's the charm. Because before we had 9 plus 2 is 11. Now we have 8 plus 4 is 12. So that gets us up by 1. If this is a 7, that becomes a 6, which is 13. Can... And we can't do better. I don't think. We 6, 8 is 14? Oh wait, yes we can. Nine, 6, 8. What is this divisible by again? 8? Okay. If we keep on going 5, 0, no. Okay, slightly better. I haven't violated any of the conditions, right? Like the 4 doesn't care. So do we get any benefit? Yeah, I was just gonna investigate this one next. That will become 88 if we subtract 7. And that 14 versus 16. Okay, yeah, yeah. Yeah. Mega, your name will be up there too on the scoreboard. If I subtract 90 is bad, but 84 is not an improvement. Is 8 plus 8 is 16? Oh, that would mess up the 9 though. I don't think the 96 is worth messing with. Because this 9 column is pretty specific. Wait, so if you subtract 8 from this again, you don't get a benefit because you go to 60. But is 52? No, 52 isn't better. 203 is not optimal. Okay. That's crazy. Should we investigate this one then? We can subtract 6, subtract 84. Is 84... No? $76? No? How would it be to generate every 5x5 grid and check the conditions? 2 minutes remaining? Okay, well, it's harder than 2 minutes. Or harder than can be done in 2 minutes. Oh yeah, I'd love to hear from Cook about finding the actual optimal answer. I assume there's a way you can do this systematically. Because I'm more or less doing trial and error here. Hmm. the 68 in the 8 row. We subtract 1 from the 9 above to make that better. Well, this row has to sum to 3, though. Or, sorry, it has to be divisible by 3. So that would have... We'd have to adjust the rest of the numbers a lot, I think. Only coding since it's in... Yeah, I'm doing it in VS Code. So this becomes an 8. You need to take at least 1 off, or you need to take 2 off somewhere else from this row. So unless you get a benefit of more than 2, it wouldn't be worth it. Maybe it would be. My bet says 203 zone. And that actually could be worth it. Now that because this digit you can make whatever you want. Well, yeah, you can make that digit whatever you want. So that could be a 7. That could be an 8, and then maybe you get. I would need to investigate the actual combinations there, but it's a minute left, so I think I'm going with what I have. The 203. It's 203 like with this exact grid. I haven't made it any changes.
Okay, that's time.
That is time. Okay. Yeah, I got mine. So
Yeah, I'm good with my last
Right.
answer.
So Don has one that sums to 203.
oh
Nice.
dang it.
Zach has a solution that sums to 197.
Oh my gosh.
And I will say, Zach had a late revelation where he started counting down from all 9s. I think if you had started that sooner, you might have found some higher
Yeah.
solutions.
I'm letting it run while we talk because I want to see if we actually get something. Don found the same one as you. Yeah. Dang it. All right. Well, GG's. That's a clear victory. I
I
well
will say
done.
that the source I got this from says the highest known solution is 205.
Oh, fine.
Oh. Does it
205.
involve an 8 in the center?
It does, yeah.
Oh, okay. So Milk had that idea, but I didn't realize it, and it was too late for me to get it.
So that does make Don 3-0, and
I was gonna say there's no hard win there. That's a. I mean, what I mean is this is flawless victory.
So yeah, congratulations to Don.
Well
You
done,
did
Don.
really well.
Well done.
I will say, do you guys want to attempt problem 4? It is strictly Jeff's problem. I just typed it up.
I have no problem with it. Like let's do it. I have a few minutes.
I will, yeah.
Yeah,
All
I'll
right,
do it.
so
This is off.
the
No
official-
pressure now.
right. The official winner is Don, but I'll put Jeff's problem in here, problem 4, because I think it's fun, and we'll see how you guys handle it. So no time constraints, just
No kind
have
of.
fun with it.
I may have to duck out pretty
No
soon,
worries. Yeah.
but I'll stay as long as I can. So
Okay,
because I do want to see
problem
the fourth
4 is-
problem, you put the time into it. So
Yeah,
I
thank
wanna-
you so much, Cook. I'm sure it wasn't easy to think of all
that.
these.
Oh well, I got a lot of help from Jeff. I'm
And Jeff.
happy how the problems are turning out. They're a little on the hard side, but I think that's better than too easy. So
Yeah.
this was definitely fun. But Don is the undisputed king of programming. You should go take your questions to Don. Everybody who has programming
All the
questions.
programming-
Everyone take
oh,
them.
no.
Why are you asking me for help? You need to get him to do it.
okay, so Don, do you want to read the question? And then we can talk about it.
Yeah, I forgot to ask you about problem 3 though. Is there an actual algorithm to solve for problem 3, or is that just like did they give that experimentally or like trial and error?
They just gave the answer.
Oh, okay.
I can link the solution, but I don't want to put it there because I want to leave it open for other people. I can DM it to you.
Okay, that works.
Okay, I did that.
Yeah,
okay, so let's talk about problem 4.
So problem 4 reads, oh, what?
Go ahead. No, you're fine.
Okay. Start with the set S sub 0 equals 1, 2, 3, 4, 5, 6, 7, 8, 9. For any set S sub k, you may generate a set S sub k plus 1 equals S sub k union f of a comma b by appending S sub k to an additional natural number of the form f of a comma b belongs to natural numbers greater than 0, where a comma b belongs to S sub k and f represents one of addition, subtraction, multiplication, or division.
Okay.
we add 9 and 9 to generate S sub 1 equals S sub 0 union 18. Then multiply 7 and 18 to generate... So the function doesn't have to be the same thing each iteration.
No, you can choose a different function each time.
Okay.
Oh dear. Okay.
Your goal is to construct a set S sub k with the smallest k that contains that very long number there. Whoever finds the smallest valid k in corresponding S sub k wins.
Wow.
Huh.
This one's a doozy.
So you start. So basically, to summarize, you start with the first 9 digits, and just through iteratively applying multiplication, addition, subtraction, what's the quickest way you can reach that given number in? And there is the one restriction that f, a, and b. So every time you apply this, you have to get a positive natural number. So you can't do like 2 minus 5 and get -3, or 1 divided by 3 and get a third. So s at all times has to only contain positive natural numbers.
Okay.
I assume there's an issue with saying that a is that number and its multiplication and b is 1 and just getting it on S sub 1.
A and B have to come from
from previous. The set. I see. So, okay.
Yeah, so you can only use what you've got from the previous stuff to grow.
I see now. Wow. And since we're not meeting, we can just like discuss it like freely. I think we don't have to like meet up.
Yeah,
again.
I was gonna say I'm trying to think about how I would even start this one. It seems like it reminds me of some kind of like dynamic programming. Or finding the longest subsequence or something. Like it's one of those problems that reminds me of subsequences and how you have to find the longest subsequence in a sequence or something like that. I don't know.
I feel like the strategy is to get the factorization of this big n number, because multiplication should be the most efficient way to get there.
Well, that'll give you a valid answer for sure, but probably not the quickest.
Yeah, I was gonna say that's the factor that is gonna be a pain.
Sure, yeah.
You can sum it pretty fast.
I thought you meant I thought you meant factor out into like decimal, like 6 times whatever plus 0 times.
Oh, I mean, no. Like, just get like the prime factorization of the numbers and try and build towards whatever like minimum 2 primes you can multiply. Or yeah,
you could try that on your computer.
Like that.
I think Jeff picked that number large to try to avoid that, but maybe your computer can factor that. I don't know.
Maybe Wolfram Alpha can factor it for me.
Wolfram Alpha can do anything, right?
Yeah.
All right. I think I am gonna have to duck out because I do have somewhere to be, and I'm thinking of, as I'm looking at the clock, it's late enough that I'm concerned about being there. I really appreciate y'all being here, by the way. Just another shout out for Dr. Cook. I'm gonna give him a shout out for he's a great streamer anyway. And you should go check out his channel. Did a great job. And thank you, Don. I'll give you a shout out too. You haven't
I should also say thanks for that. But you should also say Jeff helped me a lot with the problem. So on every problem, at the bottom, I only credited Jeff as well.
Well, Jeff, thank you as well, Jeff.
Yeah, thank you both so much.
I know you stream on occasion, so I'll shout you out as well. Sure. But not as often. Nonetheless, I'll shout you out. So thank you all, and thank you for putting this together. Thank you for watching. I hope you had fun seeing me get clobbered today. That's basically what we learned. So, well done. Thank you so much.
I was completely lost on the encryption one. That was luck there. But
yeah, but then you made me discover the bug, right? Like that's.
Well, I think I figured out what that was, Zach. I think when you copied the crypttext from the PDF, the line skips got put in as spaces or something.
Oh, did they?
Oh no!
Something like that.
Oh no! Okay,
so
that's. Oh my
God!
God!
Explain why. That's
Hold
a guess.
on, before I end stream, can I want to verify if I had like copied this differently. Like, is there a problem?
I'm just guessing here. Is that exactly what it cuts off?
Yes. Oh my gosh! Hold on, I have to run this now. This is for my honor and for my sake. If this runs correctly, I'm going to be so mad. Okay, here we
Yeah,
go.
because then you might have had that round.
Look at that. Oh my gosh.
Oh no.
Oh no. Oh, oh
That's
my
hilarious.
gosh, it comes out fine. It's like there can't be an error in that thing. Oh well, you know
I got
what?
lucky
That's
on that
easy
round.
come, easy go sometimes, right? Like if you, it's fine. Uh, good job. You're still the undisputed winner here. You did win honestly. I'm not bitter at all. I'm more angry at myself than I'm angry at anybody else. So hats off to you.
Well, thank you. It
Hey,
was super fun.
congratulations, Don. You did great, man.
Okay.
Thank you. Thank
Well
you.
Are you
done.
are you
What's
gonna
that?
stay on, Don? Is Don? Are you gonna stay on and try
Uh,
problem 4?
Yeah, I think so. Yeah.
Okay.
Nice. Okay.
Adios. Thank you. And to my viewers, we will see you all next time. I'll be here Monday. I know I'm on Don's. I'll cut off Don here so I don't have to. I don't want to broadcast
no
on
worries.
on your thing. But I'll go ahead and move off. Thanks so much.
All right. See you, Zach. Thank
Later,
you.
Zach. I'm gonna hop off too, Don, but I'll definitely be watching. This is a fun problem. So.
All right, Cook. Well, thanks so much. Again, I'll see you around. Okay. Super fun. Little competition there. I'm really surprised that I did as well as I did. I did not feel even slightly confident. Getting some music started. Let me switch my title and category to kind of like normal math stuff. But we'll still be working on this problem 4. It's just gonna be more of like a thing we're doing in the background, maybe. I'm updating my YouTube info right now. Give me a second. Oh, I hit cancel instead of okay. That's just perfect. There we go. YouTube's updated. Okay. I think I'm switched over. Oh, you know what? Let me switch over my scene actually. All right. Zach, thank you so much for the raid and for having this little competition. GG to you too. Huge thanks again to both Jeff and Cook for making up those problems. They were super interesting. Switching back into like a more normal like type of stream, but definitely in the meantime here we're gonna be looking at these problems more. So yeah, that the one that's really like all these feel achievable for me, except I'm still like a little bit lost on trying to crack that encryption one. For that one, I just kind of want to look it up and see what the answer is now that the competition itself is over. But for now, let's look at problem 4. So yeah, this one, like, feel free to just like no need to like hold any hints back or anything like this. I'm gonna just like solve this as a group here. The spaces, yeah, Zach, that was so like you had it in there a good bit before I did. It was just getting rid of those new lines. So does Wolfram Alpha factor this thing? Untrigentillion? What? Oh, could we have it in binary too, in case we needed that? That's way too short to be in binary, isn't it? Shouldn't it be longer? I don't know. Yeah, scary number names. So it doesn't factor it. The one is skinny. Oh, I guess so, Phobos, you're right. This is way more digits. Okay. Here we go. About tree engram numbers from number file. For some reason it really spooked me. I've heard of gram numbers, I don't know anything about them though. The grandiosity of them. Alright, I forget what gram numbers are about. Some are they very huge? Okay. Why are you red? Excuse me? What? Why is it red? Are these characters? Wait, leading. Oh, wait, where did that 0 come from? Oh, I don't have the leading 6 in my thing. I thought that's like an octant or something. 60693. Not octant, but octal. Or like base 8 or something. Yeah. When I copy, I had a bad copy paste. So it starts with 6063993, which I do have. It ends in 53233. 53233. Okay. It's not even an even number. Is there a number close by? Like, what's the closest perfect square? Because that's pretty easy to calculate, right? Mm. Do you have any idea probably when you do anything close optimal, you'll yield something smallish? Okay. Well, even this is taking forever to run. Using that idea, say 2, 3, 4, 5 can be written as oh, yeah, I haven't seen that format before, but okay. I think perfect square is better because of we're only allowed to multiply 2 numbers. If we could multiply 3 numbers, I think a cube would be just as good, if not better. But we have to choose the A and B, so I think that constraint makes it if you took the square root of this, I'm sure you could get a guesstimate for. Actually, I feel like there's some number theory thing for getting the closest perfect square, right? The nearest fourth powers, multiplying 2 squares together. Oh, true. Yeah. Hmm. Take log base 2 of this number. That'll give you the nearest power of 2. Hmm. I mean, we can't exponentiate though, right? With our f. Take a base larger than 9. You need to take time to add extra digits, but the bigger the base, the fewer digits you have, and so the fewer steps you take, so you can optimize over which base you represent the number in. Start multiplying 2's together. Okay. That's true. Yeah, that'll get us a solution there. And I guess 9 will get you there quicker. If you take a base larger than 9, you need to take the time to add extra digits. The bigger the base, the fewer the digits you have, and the fewer steps. True, yeah. Well, if you want base 11, well, couldn't we just do 9 plus 2 is 11, and then that's only 1 step? Can we do a general base here? Oh, this is the natural log. I mean, we can do a change of base, I guess. Okay, fine. How does change of base work? We have log base e. We want log base 9. So we do log base e of the number divided by log base e of 9? Is that how it works? Ugh. Do I need that? Really? No, I don't need that. Need all the based B digits in your set. Oh. Why does Python hate me? Loop of ufunc does not support argument 0 of type int, which has no callable log method. Does it enjoy log base or log of 9? Okay, it doesn't mind that. What's wrong with n? Is n a keyword? No, it's not a keyword. Wait, if I say s equals 9, is it going to complain about that? No. Why does it hate n? Um... Type. Go away. I don't... Ugh. Int. Int. It's too girthy. I guess so. But we have to factor it to do a product. Or we have to find a factor anyway. Which we could, I guess. Ugh. I'm glad it didn't come to having to do this problem then, because I'm like... We just want a single factor. 31. Apparently it can. This is a terrible way to check for factors, but thankfully 31 is pretty early on in the number line. Yes. Rather than generating a list of primes, like there should be a pre-built list, right? Prime range, some SimPy. I don't have SimPy. I mean, do I have SimPy installed? I don't know. Maybe we can try it. Yeah, I'd rather just use something that's built in than doing it myself. Like, I'm okay with hard coding the first however many primes. Let's just list of prime numbers. Like, why waste comma separated? First 1,000 prime numbers. Not enough, bro. Not enough. I want up to 1,000 digits. Raw? Okay. That's not it. That's it. Import CSV. It's convenient. With open. Hey, Thunder. How's it going? Ask away. Doing good too. It's a little coding competition against Zach. Probably ended like 20 minutes ago now, which was fun. Do I want that new line thing? New line equals blank? It feels weird. Mofu Mofu? What is that, Eldritch? Let me just copy in this little bit of code and then take a look. Something like that. Don't worry, it's nothing? Okay. Oh, it's getting them as strings? Okay, fine. We'll deal with it later. That problem's going to take a good bit of thinking. More than I thought, at least. Part C, but you recommend doing all of it. Oh god. Why do they love the hyperbolic trig functions? Math War 1? Oh, I won. Somehow. Yeah, I got pretty lucky on one of those, to be fair. And it sounds like Zach is having a bit of a week, so... You thought Evil Dawn was gonna win? Well, that's annoying. The fourth derivative of this thing? Yeah, okay, so since you mainly need help with C, let's look at the answer key for part A. Because I feel like there's probably a trick there that I haven't seen before. Part C made you bash your head into a wall. Math War 2? I'm not sure. Oh, you literally have to take the derivatives of it? Wow, that's annoying. It'd be cool to do it again. But it was already a bit of doing to put on this one, so... Probably not for a good while. Well, it's a pretty painful... Like, part A is just to differentiate this 4 times, which is not that hard, but it's annoying. Then B and C involves series, it seems. Casting a demonic eldritch god. That's so mean. This feels like you probably do it a lot quicker with complex variables, but... Oh, I guess you find... Okay. Don... Yeah. I'm summoning you, Eldritch. Okay, so I can see how you can figure out the pattern for every 4th one, I guess. Yeah, it's gonna be alternating powers of 4. And we get that as our pattern. Weird illegal algebraic manipulation. Okay. Where f is a function to be determined. What? Write the series expansion for y in the form f of r times x to the 4r, where f is a function to be determined. So we're predicting the coefficients is what they want us to do. Isn't it just 4 to the r divided by 4r factorial? Why would it be any... Let's look at the answer key here. Oh wait, that part had you lost. This right here in part B? It must be, yeah, okay. Oh, okay, so you got, let's explain that then. Because I didn't realize you're confused on that part. Oh. I see what's happening, I guess. You are, actually. That's kind of a weird thing about Leibniz notation. D by dx, like, of y, it's not necessarily, it's not really multiplication, is the same exact thing as dy by dx. This means whatever's in front of it, take the derivative with respect to x, and we have a y. This means take the derivative of y with respect to x. It is the same thing. It took me a long time to figure that out, to be fair. Like, I had taken multiple, I took calculus, like, I took calc 2 like twice, once in high school and once in university. And even after both those classes, I didn't really get this notation. But yeah, you're allowed to put the y up with the d by dx. Okay, so is that your only question for part B, and we can move on to part C then? Okay. Oh, you're right. I'm not showing the, there we go. Thank you. Wait. Oh. Okay, it's exactly what I said, isn't it? Why are they making it so much harder than it has to be? You don't understand the first line. Like the first sentence here, or the first line of actual math? Sentences. Okay. What that's putting into words in the math. Okay, that's putting into words the pattern that you found here in part B, where we only get something that isn't 0 for like multiples of 4. So for the 0th derivative, we get something that isn't 0, 0, 0, 0, and then on the 4th one, we get something that isn't 0. So it's saying we only really care about multiples of 4 for the derivatives. They're explaining this in a really kind of an annoying way. Can I give you just an entirely different explanation, and then maybe it'll like make that a bit more sense? Maclaurin series expansion. At the end of the day, it's just a formula. Hey, Central. So let me A Maclaurin series is it applies for any differentiable function f. And how it basically looks is you have the nth derivative of 0, right? For Maclaurin? Yeah. X to the n over n factorial. And how it looks when you expand it out is f of 0 plus f prime 0x over 1 factorial plus f double prime 0 x squared over 2 factorial plus da, 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 all the way up to infinity. So you have to keep, and usually the task is to find what these coefficients are, because we know what everything else is supposed to look like. Kind of the helpful thing of these is that sometimes the original function is something super weird and we have no idea what to do with it. But what it's saying is that no matter how weird your function is, as long as we can find these derivatives, we can make it into a polynomial that's the exact same. It might be an infinite polynomial, but that's like why these are helpful. Yeah, you can put it as like just like a summation too, like that. You sent off your last assessment of the year today? Oh, nice. Hey, Brian. Why do the factorials help in that formula? What do you mean by help? To me, they're just kind of there. That might be disturbing you, PhD. Here, over in the YouTube chat is saying physicists loves to write these as e to the d by dx f of x. Oh, is that a thing? I haven't seen that before. That's interesting. Is there to make your life worse? Oh, for the why they're there? I would have to look into it. I don't know like the derivation of these things. It might have something to do with like binomial expansion and the chooses that you get. Oh no, Tertar is saying the factorials come from the power rule, which probably makes more sense when you take all these derivatives. We can look into it more after we can hopefully answer Thunder's question here. For my other assessments, I've already got enough to pass, so at least I know I've already passed. Got 80 or more. Get the highest pass possible. Ooh, good luck. Not gonna score under 80 yet, so hopeful. What class is that for? Predicted to go search up. Okay. Are you on board, Thunder, with the first coefficient is 1, the next one is -4, the next one is 16. Like, in the actual situation that we have, we're gonna have 1 -4 16. The next one will be -4 times that. Is -48? No. 64. Like, are you comfortable with that pattern of increasing by 4? Okay, yeah. You got it? Okay. Or wait, do you mean like you got all of it or just that one part? Okay. So the thing that kind of weirds me out about all the work they're doing for part C is that, well, let me just boil down what the question is asking. Like, what we know is we have a series, let me just write this out. Cosine x, cosh x. And we know this thing is equal to 1 minus 4x to the 4th over 4 factorial plus 16x to the 8th over 8 factorial plus ... And what they want is a series in the form, like we need to make this thing somehow fit this form. And well, the x to the, x to the multiple of 4 is taken care of us, built into to the series. So all this f of r function needs to be is multiplying by -4 each time and dividing by the factorial each time. So when I see this and I look at this, I'd say, well, doesn't f of r just have to be r equals 0 to infinity -4 to the r, because we're multiplying by -4 each time, x to the 4r to fit, that, over 4r factorial. Like, I'm taking that intuitive process that we're doing here and just making it into a function with respect to r, and I'm not sure why they're doing all that extra work to get to the same thing. Oh, you see it now. Oh, okay, cool. Solution is cosine x cosh x. You can use that to recurse. Oh yeah, territory. I think that's what they did in this solution. I haven't done it like that before, but it seems to work. Can you explain how to do it with the formula? Yeah. If I can figure out what they're doing with the formula. So what are they doing in this first block of math? So they're saying for any derivative of y that's a multiple of 4, we can always write it Oh. You get the first block? Okay. Then let's look at the second block. So this is just basically the same formula I wrote on the board for the Taylor series or Maclaurin series in general. This next step is making it particular to the situation at hand. They switch from Newton notation to Leibniz, which, okay. Oh. That note, yeah, that it's the, yeah, basically it's y for our derivative of 0. That's what this thing is. This is dy by dx of 0 as a function. Or, let me rewrite that line in Newton notation, or I think it'll be a little bit easier to see. That's the thing, it's called Newton or Newtonian notation. They're saying this I'm going to rewrite in a way that I hope will make more sense to you. It'll be the same exact thing, but it's actually the 4rth derivative of y of 0. It's a really weird way of saying that. You're plugging 0 into the 4rth derivative. Y is a function of x, yes. Y is always cosine x cosh x. You're taking however many derivatives they're asking for and plugging in 0. And earlier in the problem, we found out a pattern for the derivatives. It's a soup. I really I am not a fan of this. It's really unclear what's happening. They're doing that too, yeah. K equals 4R. Because it looks like you're multiplying by 0, which makes no sense, but you're plugging 0 into a function. Wait. Why are they taking y of 0 out? Because cosine of 0 times cosh of 0 is probably 1. Yeah, I think it's 1. I already know that. Yeah. They just plugged 1 in for the y of 0. And it's because from earlier they found that any... So... No, that's where this notation sucks even harder. So if you have like multiple derivatives and you want to plug in a number, you have to do the derivatives first and then plug the number in. You cannot do like of y of 0. Like y of 0 is just a constant. If you take the derivatives, you're going to get more constants out. You have to do the derivatives first. And that's why like this notation it's a little bit more obvious what you're supposed to do. Like figure out where your y of 4r is first, and then plug in 0. And earlier in the problem, we figured out the pattern for any for any derivative of y, and they happen to show, you know, so I'm not explaining this that well. Well, they showed earlier in the problem of x, just in general, you could rewrite any derivative of y with respect to x as 4, I think, to the r times the original y. Only in this problem are you able to bring the y down, but with something multiplying it, a -4, probably. So they did some proof work with like when you have cosine x times cosh x, you can sort of bring this y outside with that extra coefficient in front. Usually you can't, though. That makes sense? Okay. A non-Euclidean traveling salesman walks into a bar. The bartender says, "Sorry, we don't serve your type. Our Coke only comes in straight lines." Ugh. What's your definition of a straight line, I guess? What's the point of multiplying by y of 0? Because it's convenient, we always know what y of 0 is, because we can just plug it in, we can just do cosine of 0 times cosh of 0. If you have the 4rth derivative of y of 0, you don't necessarily know what that is. It helps you simplify it. How it's relevant from the last step. Well, we want to make the substitution from this step to this step because this is technically a correct answer, but it's so much simpler getting down to the last step here. I think it's the point. Like, instead of taking all these derivatives every time you want a new term in the series, you can just do -4 to the power of r. And so the multiplying by y of 0 is just like a necessity to simplify it because of this relationship we found in the first block. Maybe that's a nice way. Like, we're taking like this relationship here equals that and plugging it in here. And there's an invisible of x here and of x here, and we're plugging in 0 at the same time. So they do two things at once there. What? Oh gosh. Okay. So you get how? Okay. Okay. So let me. Okay. Let's try and explain that, I guess. Are you okay with this fact that comes from the first block of math above where we were just looking? Where any derivative of y that's a multiple of 4, that's a function of x, can be written as -4 to the r times y of x. Okay. So well, first I'll say the 0 itself comes from it being a Maclaurin series, so you always plug in a 0 there. But like, it's just part of the formula. Right. And so this is y of x here. And so as part of the Maclaurin series, we have to plug in 0 for x. Hey, Joel, let's set. You have an integration by parts question. Yeah, I can do that. Once I'm done with this question from Thunder, I can work on yours. Yeah, for a Maclaurin series, we always take x equals 0. Like, it's just a part of the formula. The notation is definitely weird. I feel like this could be explained a very different way, but think you got it. I have a short question. Okay. I do have a different, or is the question related or is separate? Because I might go and do Joel's question quickly in between. Oh, okay. All right, so Joel, let's go do your integration by parts question. I should really not use, I need to replace the ink in this black marker. It's smudging. Oh God, that looks terrible. Okay. So Joel, you want to integrate e⁻²x by parts, right? Did I copy down your problem correctly? Oh yeah, I'm PhD. So, sorry, I was seeing what you were typing, but I wasn't sorry, I wasn't responding. Yes. Okay. Thank you, Joel. And actually, that's a really good metaphor to use with cosine and cosh as well, considering that they can be expressed as exponentials. But yeah, it's basically the same idea. It's probably why we get that kind of relationship, actually. Okay. So I'll show you the way that I was taught to do integration by parts. It is taught in a different format, but fundamentally the same thing. The way that I was taught and that sticks in my head really well is we're going to say that one piece of this is equal to u, and another piece of this is going to be equal to dv. We're going to take the derivative of u and we're going to integrate dv. So when I do integration by parts, usually a really good thing to take the derivative of is a polynomial like x, or like just x squared or x cubed. Because of the power rule, these will usually kind of like, I say it degrades. Like the x here is just going to go away once we derive it, and that's desirable. And so that leaves dv to be e⁻²x. So we take the derivative of u, du equals dx. Oops, sorry, this is dx. We integrate each side here. We get v equals 1/2 e⁻²x. And now the formula is u times v minus v du. And for whatever reason, the act of drawing that little arrow thing helps me remember it. So u times v is x times 1/2 e⁻²x minus v du, and because of the du, we are implying there's an integral there. So v is 1/2 e⁻²x. du is just dx with nothing extra. And so this we know how to integrate directly because that x went away. That's why I kind of think of it as degrading, where after just doing integration by parts once, we've completely removed this x and we've got something we can integrate directly here. So let's go ahead and do that. I'll rearrange that a little bit to be x over 2 e⁻²x. This, doing a mental substitution with u equals 2x, we're going to get 1/4 e⁻⁴x. And don't forget, oh, sorry, 2x. And don't forget your plus c. So that's how I integrate by parts. I hope that makes sense. Let me know if you have any questions. Yeah, it's like a similar pattern as what PhD was doing. Not the same exact problem, but like you kind of get the same thing back just with a coefficient. Makes sense? Awesome. Let me know if you have any other questions. So yeah, Thunder, I guess I'm ready for you now. Memories of integers are hard to get, but yeah, they can quickly get pretty large. Oh, okay, gosh. So I feel like they're gonna want. Oh, wait. Um, so your question is, can you apply this method to this differential equation? So it is a frequent thing in differential equations that if you have something in front of your highest like derivative, you have to divide it out. This technique does not exactly work though, because when you divide everything by 4xy, you have a division by y over here, and that makes it a nonlinear equation. Yeah, the x squared over y is a problem. Or I guess x over 4y. Yeah. There might still be some integrating factor or something, but it just wouldn't necessarily be the same integrating factor. Difference between linear and nonlinear. Oh, that's what I was trying to say verbally yesterday or something. It's easier to show in writing though. The definition is if it's linear, it's possible to write it basically in the form that was given in that little prompt that you showed me. If it's possible to write it in this form, it's linear. If it's not, then it's nonlinear. So if in our case, it wasn't linear because this was not solely a function of x on the right-hand side. It's like x over 4y or something. And that y on the bottom is what makes it nonlinear. And so a nonlinear can kind of be anything though. So like, if I said sine of dy dx plus 1 over 2x y equals x, even, this is nonlinear because that sine of dy by dx makes things weird. Yeah, I would say these are both nonlinear. Sorry if that wasn't clear. If you could magically take this y away, you would have a linear equation. And the idea of being linear isn't just for first order either. All linear really means is you have nothing really weird happening with your y's. So like you can write each thing involving y alone into the power of 1 and no like external functions on the y itself. Or if I'll do another nonlinear example. Y squared that's nonlinear because of the squared. If it can't exactly match this format, it's nonlinear basically. If it's instead xy over 4, that's a good question. So if we instead had dy by dx plus 1 over 2xy equals xy over 4, this is going to turn out to be linear after we do some manipulations. So I'm going to subtract this over to the left side. And I'm going to factor the y out from here. This now matches this format, so I'd say this is linear. So you do sometimes have to rearrange things to figure it out. If it was xy squared over 4, it would be non-linear, because you can never get rid of that. Like, you're always going to have a... Like, you could try to do the same thing, but you would end up with, like, xy over 4. And that makes it non-linear. Like, there's no way to get it into that form if the y is squared. Hey, Krim. A little bit, yeah. Just talk about what it means to be a linear differential equation. Try and find a good way to ask your question. Okay, sounds good. I'm curious to investigate Peach T's thing of asking why the factorials are there. Tiratar earlier said it's because of the power rule. I assume what we get when we start taking derivatives of these things here. So first we use a general representation of a power series for a function. And the goal is to figure out what these constants are. So if we let x equals a, which we're talking about a Taylor series, all of these terms go away, leaving us with just C0 is equal to f of a from the left side. We take the derivative of the function, so we take the derivative of each side here. The C0 goes away. You end up with a C1 plus 2C2x minus a plus 3C3x minus a squared. Plug in a to get rid of all these terms after, and you get just C1. But then you find, if you do it with the second derivative, you now have this coefficient of 2. So, f double prime of a is equal to 2c2. So you divide the 2 over. Okay, so I see where it comes from, the power rule now, because when you go to do the third derivative, the power rule will get you a 3 times 2. Since you have Taylor series notes open, I was wondering while doing integrals with an infinite series, in it, how can it be we can interchange the integral and summation sign? That's a good question. I think the answer is that they're both linear operators, and those have nice properties like being able to switch their order. But I bet someone who knows math better than I can give a better answer. Because someone who's good with analysis will be able to answer this better, but I was kind of taught that you're allowed to do it because they're linear operators, and that was the entire explanation. This is a little bit extra, though. I'd like a little... So it's not quite so terrible to look at. Yeah, I don't understand it either, if that makes you feel any better. This person says that a finite sum and integration is trivial, basically, which it doesn't seem trivial to me. It's the distributive property, Teratar says. Is it? Does it have to do with thinking about an integral as a Riemann sum? An integral is a sum, Teratar says. I guess that's it, that... if you have an... I don't exactly like what the proper way to express this is, but I guess the point is that if I were to take the integral, I'm always allowed to rewrite an integral as a Riemann sum if I want. I shouldn't reuse n. Oh wait, actually, I forgot there's different ways of representing this Riemann sum. But I will use n here, and I'll use the limit as the partition approaches 0, because that's the way I remember being taught for a Riemann sum. But the actual thing isn't important here. I think I equals a to b delta x f of x sub I, or some. I might have the exact Riemann definition incorrect, but the important bit is that you're allowed to drag this limit outside, because it shouldn't matter if you add things and then take the limit, or take the limit and then add those things. I think this is a very non-rigorous explanation, but it's kind of maybe the simple thing in terms that the both of us will understand. And then you're allowed to interchange two summations, which I would need to think about more to really be convinced of it, but that seems reasonable to be able to interchange summations. Terrible. Thing there. And I think the delta x can come out front too, because it doesn't involve the delta x isn't affected by the end summation. And so I think what you end up with is, oh, this is now a new Riemann sum with this as our function. The notation is far from perfect here, but that's kind of like my on-the-fly demonstration, I would call it, not even proof. You can do some of the discrete sum is weird. Well, an integral an integral translates a discrete sum to a continuous sum. So it is weird, but I think it's reasonable to be able to find a translation there, I guess. But yeah, it's a very good question that maybe Zach could give a better answer to, but trying to figure it out on the fly, I think that's kind of the idea. Dr. Cook asks, can you find x unequal to y as such that x to the y equals y to the x, how many pairs x comma y? The answer is no, I can't find that. I'm not very good at those questions at all. I'm going to be honest. Okay, this is what Thunder sent. This is true. Yes. Yeah, I got to say, anytime you have a dy by dx, there's a hidden of x there that we usually just chop off. It's kind of terrible, notation wise. So yeah, I agree. Thunder. Territar put the sum of the first 100 digits times the sum of the first 100 digits. You distribute it. Oh, is that for why you can interchange summations, Territar? Think of integration. Oh, okay. Oh, I think I see what you're saying. Okay, yeah. You can think of integration as a continuous sum. They can take double integrals, then triple. Continuous number of integrals. Oh yeah, Dr. Cook sent a DM talking about the Visionaire cipher. Test all 3, 4, 5 letter keywords, filter the output for common English words of length 3, 4, 5 characters or less. You probably have hit on key or Kiev that way. Yeah, it never even occurs to me to try to import some kind of dictionary. That would have been really helpful. Might be worth trying to go back and solve that one properly. I did thunder, although I feel like I got a little bit lucky. Sorry, one thing. I have a snack because I didn't fully eat my breakfast this morning, but it's also really dry. Okay, God. I realized how thirsty I was until I started to drink the water. What topics have I studied in physics? Have you started mechanics? So I'm not right in the head because as part of my bachelor's in applied math, I took 2 semesters of physics, one on mechanics, one on electricity and magnetism. And now I would bet like 8, 9 years after I took that class. That's weird to think it's been that long in physics. I think it was my freshman year of college. I just randomly decided that I wanted to jump into this super hard E&M textbook. We're currently on chapter 4 about electric currents. I remember almost nothing about mechanics, so but the math in this E&M has been super interesting. So at some point, if and when this thing comes to an end, mechanics might be a nice thing to revisit. Maybe I don't think I want to spend as much time on mechanics, but like maybe like an easier book than this one. But this is going to occupy me for how long has this reading group been going? Let me scroll like all the way up. No, I can't. Okay. I mean, I have a pinned message that I can, since May, and we're 4 chapters in. So it'll be a while before we get, like, it'd be cool to get at least some Maxwell's equations. But, and that's chapter 9, which is nearly at the end anyway. You hate mechanics and dot product and vector projection. I don't disagree, but they are important, unfortunately. Look at, where is this guy's neck? What the hell? It's like, or like he went like this and he pulled his shirt up. See? I'm visionnaire. Anyway. Hey, Anders. Uh, I feel like I got a bit lucky, but I managed to sweep it. We were doing best 3 out of 5, and I managed to win the first three rounds. The questions were really good. Thank you, thank you. There was this one, the fourth problem that we never got a chance to do that I started to work on a bit. Then I was getting distracted and looking back at like some information about problem 2. But all the questions, I think Cook posted them in my Discord too afterwards. They're also posted in Zach's Discord and broadcast prompts. If you're interested in like taking a look at them. I think JeffCGroves did. I think that's what Cook said. For this one, I was working on finding some prime factors of it when I got distracted with some other questions. But my idea for this one was to, like, it's probably not gonna be the optimal thing, but what is to find the perfect square that's closest to this and try and build towards that perfect square. The number is so stupidly huge though that it's pretty hard to do anything with it. I think oh yeah, there's also a strategy that Cook and I think someone else were suggesting to calculate the log base 9 of this thing, and you could always multiply 9s as many times as you want. If you can factor that, you probably also crack passwords. Okay. But this number is too big. It seems to be too big for my normal the log function that I would use to actually work on this thing. Oh, that's right. That's why I was trying to at least find 2 factors of it. Or like, find a pair of factors. So we could use log rules to split it up into smaller numbers. 31 goes into it. That was the smallest factor that I found. But I haven't fully gone through this. Because you have to find a pretty big number just to even appreciably reduce this thing. Hmm. Yeah, if this one oh yeah, sure. Let me grab it from VS Code, because the copying from the PDF is a little bit weird. Dr. Fish, the person you love the most this year. Dang, Joseph, I was really gunning for that spot. K equals n is a solution just by adding 1 over and over. That's true, yeah. Hmm. Well, I guess it'd be slightly less than k equals n because when you do 1 plus 1, 2 is already in. Oh, actually, no, that's still a step. Never mind. It's not important. It's not really important anyway. We could just naively keep multiplying 9, I guess. Like, we don't necessarily even have to figure out what log base 9 of this thing is. Why don't you just start multiplying 9s? What about 9 times whatever the last thing was? That would get you there even quicker. Let's not worry about this code. Check out if you can factor out some powers of 9. I mean, I'm thinking I might never want to take log base 9. Just keep multiplying 9 until we go over. And then I guess we can start adding some of the previous things that we got. I mean, we can do like, we can quickly check for some powers of 9. $30? I don't know what's a reasonable number to go to. If n mod 9 to the I, well, we know 1 won't work, is equal to 0. Wait, n, what am I doing? Oh, big N, there we go. Print I. No powers of 9 up to 29 are factors, it seems. Yeah, I think that's what I... Oh, true, yeah, I wasn't even thinking about it right. So I was gonna do like 9 times 9 squared, but I could do 9 squared times 9 squared. You're right. I think it's the way I like the most here. So far, that I've heard. Wait. How am I doing this? No, I don't want that. Well, do I want that? The last one squared? Yeah, that's good to do. Nums dot append the last one of nums squared. And doing this makes us have to increase our k. Maybe I should make it k to match the prompt. Um, and then we need to start doing addition, probably. Is there something better that we can do? Yeah, I was wondering about. We could add the lower powers of 9. I was wondering, like, instead of squaring it, can we just multiply it by the previous power? Is that going to put us over as well? I was trying to figure out if I could be assured that doing like the last, instead of doing the last number squared, do the last number times the second to last number. But that might not be safe either, though. Approach basically corresponds to writing n in base 9. Well, it's like a weird. It's like kinda, but like we're doing power like 9 to the powers of 2 rather than every power of 9, right? I guess there's zeros filling in between is what you're saying. Yeah. Okay. I guess that's fair. It's gonna be like a base 9 number plus a number of a different base, I guess, for this next stage. Um, okay, so while nums -1 is not equal to n, or I in range. I feel like we should be able to multiply though to do it a lot faster. Multiplying feels more dangerous for some reason. No. Oh, what we should do? No, 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 no. We can do a second stage between these two stages. I think this is better. How do we... Is that how we step backwards, starting from the end? I think I need to switch my start and stop. Yeah, I need to switch my start and stop. Think like that. And then we do a similar thing here, but with addition. I'm going to rate this cautiously. I feel like this step should give me some kind of assurance to make this next loop a little bit simpler. But I don't really understand what I'm doing here, so let's just not take that risk. Well, okay, no. We know we can't multiply by 2 anymore. Right? Because we've already tried to multiply by 2. I think. Yeah. Um, I think this is what we want. Let's see if this does anything for us. And this might take forever to run. Oh wait, I goofed. That's what we want. But doing I don't know. Is it as simple as doing it to those two numbers separately and adding my results? That seems, I don't know how that works, I guess. It's not, yeah, I don't know. It is that simple? I don't understand why. I'm not saying that my strategy is good, but just one more step to add them. Oh, we independently get to each of those two numbers, and then we can add them. Huh. So I'd want to package this entire thing into a function, I guess, which I could do. Okay, this probably isn't gonna run in any reasonable amount of time. How do we how do we exactly want to? I guess I can convert this number into a string. And use string operations to cut it in half. But I kind of need to, I don't want to hit run on this code and have it go through all this without def get do nums k. I don't know what to call this thing. Is there, I don't know how this naming conflict is going to resolve, but I'm not going to worry about it for now. What is the length of this number? Actually, wait, if I just make it print out n, does it abbreviate it into scientific notation for me? Nope. I feel like there should be a some kind of way to format this. I'm not gonna bother to Google it though. Okay, it is a length 100. Oh, okay. Number. So it can be written as something like 6 times 10 to the 99. She's probably just a simpler way of doing it. There we go. Is times 10 to the 100? Really? Oh. I guess I was visualizing moving the decimal to the right incorrectly. Ugh. It's that over 2. Oh, that's fair. Yeah. Oh my god. Wait, oh, you're right. You are right that you're wrong. Yeah. So is it 99? Okay. Either way, I guess it is important. We need to know what power we have. Um... Oh, it's a float. That's why it's... Oh my god. L is the best variable name because it's very easy to figure out what it means. What? To be fair, I completely accepted you, or accepted what you said. Oh, I'm doing Java. Why can't every language be Java, you know? Okay. We have two numbers, presumably 50 digits in length. $50. $50. Okay. And we're going to multiply these by 10 to the 49 because they're 50 in length. Well, N1 is times 10 to the 99. Well, we need to actually multiply by 10 to the 99, right? To the 49. And we can do a little sanity check here and print n is equal to n1 plus n2. False. Dr. Cook, how dare you put something about race, ethnicity, or religion in my... What? How is that? Okay. Automod's going crazy. Oh, wait, this is... Oops. These should be decimals if I'm doing this. It's still false. I mean, I could chop off these exponents and do it separately. Ugh. Horizontal scrolling is the worst. It's still false. Why does it do this one in scientific notation? Do I still have... Well, Ralph will probably tell me the scientific notation for this thing, right? It is times 10 to the 99. The original number. Just to verify that thing that... .0693. It must be the end that's wrong? Is it times 50? Oh, I'm not doing, false. What? Why is this so difficult? Oh, okay, still false. Is it just because the numbers are too huge for Python? It's just acting weird again? Like, this could be some kind of, like, overflow issue or rounding issue or something. I don't know what the proper term is. Yeah. PhD, I didn't give the primes idea a good try. The list of primes that I grabbed off the internet, I realized they only go up to like the thousands. And dividing, I want to divide out a number times 10 to the 30 to make an appreciable difference here. Greater and smaller. Yeah, we could try to go for like 4 pieces. Oh wait, oh my god. No, it's still false. No, wait, I did need the decimals if I don't know, man. I shouldn't have to worry about a number that's too big, apparently. Yeah, it's possible I overlapped. I didn't do my string stuff correctly. So we have 406, 145. Oh, hey. That seems okay then, because it's that exact part of the... It's in some kind of error range. Yeah, I would divide them, right? Excuse me? Last I checked, that means they're equal, Python. If the type was mismatching, it's possible. One's a float, one's a long. It shouldn't, but let's see. Long is not defined int. False. False. I'm willing to say that I'm doing it right, and that Python is stupid. I feel like I do need to build the exponents into the original numbers, though, I feel like. Otherwise, I think I'm going to get the wrong answer. 2n as a second number. I don't know what that means, Peach Tea. It's a large boundary? Wait. N1 is still a huge number. I don't think... Does this breaking it up even work? Because I think I need this times 10 to the 99. Unless I separately also make 10 to the 99 and multiply it later. But that sounds like it's going to really... I don't know if that'll be more efficient than some other... Like, I don't think it's getting inefficient. I guess it wouldn't take that long to get to 10 to the 99 because we can do, like 10 squared, 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 squared. I guess that's true. Yeah, okay. That's the benefit of doing this. Okay. And so we should get rid of the decimals then. Okay. Actually, you know, I like this comment being where I had it. Okay, so... Yeah, there's a couple of ways why this probably isn't going to be like the most efficient, but it'll at least be computable, I guess. Um, how do you make a set in Python with curly braces? I think I'd rather you be a set. What? Oh wait, can you append to a set? Oh my god. We can union, right? No, we should keep it as we should keep life simpler and what I know. We'll convert it to a set. We need to be a set, and we'll put it back to a list after. I just want to avoid. Actually, no. I don't need to think about sets. Don't think about sets. We want nums. We want k. And we want n. And I'm going to hope that that n up there doesn't conflict. I needed to return nums and k. I don't know how passing by reference is going to work here versus by value. I'm just going to try doing it and see if I get the right answer. I don't know if this is necessary, but I'm going to do this. This seems really stupid, right? Can I just do... No, this is too stupid. I'm just going to naively think that this is going to work. Yeah, if it doesn't work, I'll figure it out after. All right. I should have put progress statements. True. It's probably better to not have the decimals then, right? But no, this would be 10 to the 50 though. Because we want 50 zeros added onto this thing. I think. We'll know that that one's done. I am not getting the final answer here, actually. I guess I'm only getting the 3 pieces and not the final N. Let's see if it gets N1 done in a reasonable amount of time, though. I think that's not. If N1 isn't done by now, I think we're still not doing it well enough. So we could split it up further, do it in quarters. I think there should be a better systematic way. I feel like I could write something that would do it for an arbitrary number of partitions here, but I don't really feel like it. How's I splitting this thing up? Yeah, maybe let's jump straight to 10 digit numbers. I like that even more. I mean, at that point, we're going to want an array of this thing. Rather than N1, N2, N3, N4. But that's fine. Honestly, okay, rather than just do the old... Oh, wait, does this tell me the character length? 12 select 10... Ah, okay. Wait, just... I'm going to rename this array in a second. 10 selected. 10 selected. Oh, there's a leading 0. That sucks. We can... Well, we just chop the 0 off for the sake of the array. 20 selected. 10 selected. I'm looking at that thing down there. Uh, 30. Ugh, chop a 0. It is going to add a lot of steps, but so are you thinking that 4 25 ditches is better? Yeah, I cut it in half by putting it into a string, but all right, fine. You know, Cook, you sold me. Let's do 4 digits or 4 numbers. Wait, what? Cut, paste, cut. No, that wasn't a cut. Ugh. There we go. There we go. Hey, bud. I don't know how big of a number Python can handle either. Nah, I'm full sending. What's our new breakdown though? We need to add 75 zeros, then we need to add 50 zeros. Then we need to add 25 zeros. Yeah, it does actually blow up kind of quick with the number of things you need to find. I mean, I think for the powers of 10, like maybe on the way to getting 75. No, you don't. If we're doing it, I don't know. How's it going, Bode? Doing good too. Thanks for asking. Let's do a little check there. Five times 5 is 25. Okay, sure. Hey, Jamal. Yeah, what's the problem? My final case under 15? Oh god, I don't know. So I need to get, just in stitching these together, I'm gonna have like 5K things, so I don't think I'm gonna be under 15. So K plus equals 2, nums dot append 10 to the 50, nums dot append 10 to the 75. Justify why I can do this outside of a loop. It's 10 to the 50. Oh, well, Jamal says, let a and b be positive integers such that ab plus 1 divides a squared plus b squared. Show that a squared plus b squared times ab plus 1 is the square of an integer. Oh, divided by. Probably over to the Twitch chat. I'm very terrible with these problems, but someone around might know that. I'm not sure that I can solve it though. Well, yeah, probably like those. I'm not even sure like where to begin, unfortunately. Oh, I don't know. You'll try it? All right, thank you, Bode. No pressure. Jamal, it sounds like Bode over in the Twitch chat will try it. So if you stick around for a bit, I'll pass along the message, but I'm pretty terrible with those types of problems. Well, making 25, it's useless to get 25 in the array because f can't be an exponential. We need 10 itself to be in the array, and then we need to like do 10 squared, 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 squared. I think. And so how do we stitch these together? Nums.append. Yeah, no worries. Times 10 to the 50, nums.append n3 times 10 to the 25. K plus equal 3. Nums.append. I should really just calculate this once, right? N1 plus N2. Okay, you know what? Let's just do all out at once and just track what. Oops. Well, I don't know why I'm making my code exactly match the. No, that's only 3 operations, right? Because we add these two, we add the result to that, we add the result to that. So that's 3 operations. It's not even getting N1. Yeah, I don't think I would have been able to do this one during the actual like I mean, if it was during the competition, I probably would have gotten a at least like a crappy answer, so I have something. Like just multiplying nines. I guess I could definitely do. I guess I hope so. The number might just be too big for. Perhaps you'll be able to take logs of 25-digit numbers. Hopefully. But I don't really want to. I am getting like a little bit tired, so I guess today I'm not going to like start from scratch and go back to the log approach. Oops. All right. Yeah, this is taking too long. Did you error? No, that's just the trace back. Hmm. I'm not sure. I do want to look a little bit more at that cipher stuff. I made that louder. I hope that was loud enough for your butt. Oh my god, I even saw it pop up before it played, and I was still scared. No, I don't want it to be ear breaking, but yeah. I don't remember what this was doing anymore. You thought the point of that was so we could get their log. I thought it was just so we could have something that's easier to do calculations with. The approach was step one is we keep squaring the highest number we have until we can't. And then once that stops working, we take our highest number and multiply by the next highest number we can until we can't. And then when that stops working, we take the highest number and we start adding the highest number we can until that stops working, basically. There's probably a bug in it, but... So what's up with this thing? Okay. Kasiski was the first to publish a successful general attack on the vinaigrette cipher. You're gonna talk about what the... Okay, it's down here. Sometimes encrypted using the same key letters. Oh. To repeated groups in the ciphertext. So you do have that repeat there. Do you dabble in 3D stuff? Like for coding? I've attempted to dabble a little bit. There was a program I was working on that I've been too lazy to really work on much recently. I want to get the electrostatic field due to a tube of finite length at some point when I'm not lazy. And I can't make the rendering show on stream, unfortunately. But here's a screenshot of it, and you can actually like, scroll this around. There's a new AI out there called Meshy AI, and it makes 3D objects. Oh, interesting. I feel like people are going to use that for evil, to be honest. That's where my mind goes, at least. Oh, thank you so much, Bode. Jamal, if you're still around, it sounds like Bode may have found something that I'll show on stream. Did I see it? Cybertext may not have been long enough. It's problem 2, I think. No worries, Bode. Can we like just eyeball a phrase that we or a string of characters? DQ, DQ. Oh no, that's where the similarities end. Okay, you're still here, Jamal. Thank you for hanging out. Towards the end, I was thinking like this 5v in a row thing seems like there should be something we can figure out about the key from that, but I couldn't really get very far with it. Like, do we have like QBird anywhere else here? I'm sure you read a program that like looks at every like that looks for patterns and like for things of a given length. It wouldn't be that hard. Yeah, just by eyeballing it, I can't easily see a repeated thing. And you'd want these things to be relatively close together, so you have fewer options to check for keyword length. I don't know. Oops. And then once you know how long the key is, you still have a pretty difficult task ahead of you, to be honest. I'm still not, like, that's definitely helpful, but I still don't really know quite where I'd go with that. The index of coincidence. What the heck? The probability kappa sub p that any two randomly chosen source language letters are the same. Probability of a coincidence for a uniform random selection in the alphabet. Yeah, I don't quite get what those terms are doing. Oh, so once you know the length of the key, oh, this is at the very end I was trying to do something like this, but I didn't know the length of the key, so I guessed that it was length 3 just to see what I would get. Oh, I see Bo posted a part 1. I'll bring that up. So Jamal, I think this is going to be part of the solution, Bo's still working on the other part. The not so important part, second part is where things, oh, okay. I'll still like start looking at it though, because for me this problem is going to take a long time to understand. Wow, this is I think this is beyond me entirely. Probably I'll keep it up on the screen so Jamal can see it. It's not even the actual like full thing either. Hmm. Actually, Jamal, if you do want to copy this to look at yourself, maybe take a screenshot of it or like rewind the video, because I don't actually just want to sit here now that I think about it. I'll leave it up for a little bit longer so you can get like a screenshot or whatever you need, but I'm gonna switch the view in a second. Yeah, sure. Okay. Then I'll show the rest of it when it's ready. I'm kind of curious to revisit problem 2 a little bit, just because I think it'd be interesting to see that frequency analysis for myself. So this is the actual keyword, which we're gonna use that to. We're not gonna. We're just gonna have knowledge of the length of the keyword, because I don't feel like trying to work out that part right now. This thing is length 11. I don't have to count. So we want to split this thing up into split this ginormous string up into 11 columns and however many rows that we need. I don't want to do that. Length. Keyword, and then, oh wait, this is rows by columns. So I want the length of keyword many columns, but for rows, I guess I want floor np dot. Ugh. Okay, good. NP does have a floor. Length of encrypted, then add 1 to the floor to be safe, because it might not be evenly distributed. Why doesn't it scroll me to the left? Thank you. Oh, Ronnie. Oh, wait. You should be a VIP, because that's what real life friends get. So earlier this morning, I had a little coding competition with another math streamer friend. And we were basically doing like a best 3 out of 5 for the first to finish the problems. Oh no, you got an ad. Are you out of the ad now? There we go. Okay, so yeah. First off, to be honest, I was just rambling anyway. This morning, oh, it's already 4:40. What the hell? I didn't realize it had been 5.5 hours. But this morning I had a programming competition with another math streamer friend, and we're doing like best 3 out of 5. Like we each worked on the same problem at the same time, and the first to finish the problem took that round. And so I managed to win, but I want to revisit this problem, and I was looking at another problem that we had for the competition too. Oh, awesome! Let me bring up that thing then, Bode, because the problems were super interesting. So I wanted to like learn a bit more about them. Yeah, I was doing everything in Python today. Little section 2.5 just above this. Oh, in the Discord text. Okay. All right, so Jamal, I'm gonna ask you if you can take like screenshots. There's a few different things that I need to show. So here's what Bode put in my Discord. Actually, yeah, this might be legible on stream. Or, you know, it's hard for me to show everything here, but this is like the next thing right after what I just showed above. And then the image, and then this is the conclusion. And I can show the image in bigger detail. Sorry, it's a little bit like pieced together, but you know, it you know, it just is what it is. Screenshotted. Okay, nice. And then I'll show the image now. Hey, Ishan. A little bit. I'm not terribly good with it, but today's been a lot of coding stuff. This is a crazy problem, by the way. We'll see now. Okay, if you have any questions and Bode happens to still be around, let me know and I'll ask Bode. Method is called Vieta jumping. Oh, okay. Yeah, Ishan, I'll try it. Problem you were discussing. Oh, really? Well, yeah, I didn't even try it myself. Bode over in the Twitch chat was able to solve it, I guess. I sure as hell could not, though. Let's go what you are posting here. Geez, well, hats off to Bode then for just casually taking it on. So what what's the purpose here? Or... Oh, okay, here's the prompt. Didn't recognize it, silly me. Technique is popularized by this problem. He did say it seems similar. Oh, okay. You have the solution with me, the math problem you were discussing. Oh, okay, yeah. Oh, wow. Okay. And then this is I guess each of us happened to have this one offhand, so I'll show it on stream too. In multiple parts. So I'll show this for a little bit on the screen, and then part 2, and then I'll look at Ishan's coding problem. But yeah, Jamal, this is for your problem here, apparently. If you are still here, if not. Then I'm switching to the other image. Zoom in even more, I guess. And I'll show it for a little bit longer, and then I'll go to the coding thing. Oops, sorry, I'm shaking my camera. Okay. Oh, I thought this time limit was like the time limit for you to write the code. It's like 1 second? No, it's the time limit to run. A word is too long if it's strictly more than 10 characters. All too long words should be replaced with a special abbreviation. The abbreviation is made like this. So you write down the first and last letter of a word. Between them, we write the number of letters between the first and last letters. Numbers in the decimal system doesn't contain any leading zeros. Localization would become L10N. Internationalization would be I18N. Okay. Automate the process of changing the words with abbreviations. At that, all too long words should be replaced by the abbreviation. So not too long should not. Okay, this isn't so bad. The first line contains an integer between 1 and 100. Each of the following n lines contains one word. Lowercase Latin letters possess lengths of 1 to 100 characters. Okay. This actually looks a bit like this. Looks like, oh yeah, it is Python. Okay, that's convenient. So it's just whatever the input is, we convert it to an int. Str. Oh, okay, so this is the output you got. This is the answer that was expected. Okay, yeah, it looks like everything's a little bit off here. For I in range n, Joe is output I plus 1, or input I plus 1. String.append Joe. So, okay, you're instead of doing the input like line by line, you're just getting all the input out of the way up front and putting it into an array. For I, comma s and enumerate string. I haven't seen a for loop like that before. You can like zoom in even further so it's hopefully easier to read. This code uses things that I haven't seen before. I have a hard time troubleshooting it. Like, what does enumerate do? Oh. Index and printing. Oh, okay, so, oh, I didn't know you could do that. So index and actual value. That's really nice. That could have come in handy a couple times. It's good to see that. So I guess I think the issue I would take here is with the letter count line. Maybe how can I do this? Or at least how it's being used here. So like, I guess if I was writing this code, and I'm not too good with programming, but like, you could just make that length S, I think, and in letter count, you would want to do it letter count -2, right? Because we don't want to include the first or last letters. And I think somewhere in here we need to skip over the first line, or we need to it seems like the 4 that's telling you how many words there are is also getting, like, this loop here is affecting the 4 when it's not supposed to. Well, maybe in theory, it should just go straight to the else, I guess, which is okay. So yeah, I guess I want to see how the code does after making those 2 changes, and then I'm not sure if it's still wrong, then I need to keep on thinking about it, I guess. And I see you going back and forth with VOD in the Discord, so no pressure on like getting back soon, but oh, you might need to do s.rstrip to get rid of the new line character. Actually, yeah, the new line character might be messing things up in this. Actually, so then undo. Maybe. It might not be necessary. I'm not quite sure. All right. What was I doing? I wanted to try out the frequency analysis thing. Um, okay, cool. I do need to make this match. Like, this part isn't gonna quite work here. Um, oh my god. Can try that, VOD. What am I looking for? Okay, that fourth word I'm not retyping. Pneumo.
Eosis. I'm abbreviating that last word because there's no way in hell I'm retyping that last one. It's like 50 characters. Oh wait, you know what I can do? I can simulate it. I know it's supposed to be 43 characters between the first and last one. So I'll just do 43 A's. Because it doesn't matter what the contents are. That's 41 A's. Pretty close. All right, so that's 43. Now how do I read it in a file again? Hmm. 54. Going to sleep? It sounds good, Bode. Sleep well. I'll see you around. Thanks for help with that problem. So this first part of my code just can't match what you have. Because of how that website works, but everything else we can check. So I think I need to chop all that off. Ugh. Oops, open. What? It's not giving me an error message. Oops, I'm not doing... Ah. Oh my god, why is it being stupid again? Ah. Oh, because I'm... Wait, fine. No? Okay, I have no clue why I can't make... I've been having issues trying to read in text files for some reason. I'm just gonna hard code it because it's being stupid. And for an integer. So I was saying to just change that to be the length of S. If it's greater than or equal to 10, I want that to be -2. Okay, right. Length string S. You kidding me? And 1843. Okay, so I think my edits work, Ishan, or Levy, I don't know if you prefer one or the other, but whatever your code is doing to get the length of it, I don't understand it, but I don't think it's working. And I'm not sure why you wouldn't just use the built-in length function in Python. And then when you go to format the string, you need to subtract the letter count by 2 because you need to remove the first and last letters from that count. Other than that, though, I think your code is good. Yeah. I'll just send like that one part because the input part I can't really help with, or this seems a little bit weird to me, but input is always. I think it depends on the website there. So if these don't work, then I assume it's going to be something with the input. Good resources to learn Python. You're good at the math part, but the coding and syntax, I'm a beginner. Yeah, I kind of learned from my computer science classes. So now, or like I learned like Java and C++ from my computer science classes, and now that I know the basics, it's not that hard to pick up a new coding language. You just have to learn the syntax, basically. So what I was using is just like the Python tutorial that they include in like that's actually provided by like people who make Python. But I didn't need that much of an introduction to like the concepts of programming. In college, but you want to do them on your own. Yeah, that's the part where I don't have a very good resource for you, because I just learned it from my class and I haven't had to try to find one. But like, if you do try to use this, I would skip over chapter 2 here because it's probably not all that important for what you want to do. It's like, I don't know, this thing, like it'll be good enough to learn Python directly. Kind of like the overarching concepts. They might not go into as much. And I'm not really sure where you go to learn that, to be honest, besides a classroom, unfortunately. Thought you mainly teach Haskell and C, so you want to do the Python thing. Oh, okay. Yeah, I've been trying to learn some Python. It's honestly, it's not my favorite, because I am more used to like Java and C++, but it has some nice things about it. It makes things more convenient if you can get used to it. Okay. I think I might do Bode's Redeem and then call it. So Bode redeemed a drawing to draw myself solving the inequality multi-sided math discussion, dressed like a prisoner with that one cartoony thing on his leg, which I assume he means the ball and chain. C seems harder though, IDK. C++. I don't know about Haskell or anything about how that works. In some ways, like, in some ways it can be harder. I think it's a bigger learning curve for C++. There's a couple of extra things you get to worry about in C++ that you don't have to worry about in Python. But having come from C++ and going to Python, I feel like I have no control over anything it's doing, and I'm never sure that Python is doing what I actually want it to do. So kind of in one sense it's harder, but in another sense, C++ is just more clear of what you're doing, to me at least. It's like the biggest example is that in Python, when you declare a variable, you don't have to say what type this variable is. In C++ and Java and all that, you have to say it's an integer, and it'll only accept an integer on the right-hand side there. So in Python, you don't have to worry about that ever, but I kind of like having to worry about that personally. Okay, yeah, so the 1, 2, 3, 4 at the beginning is still happening. I see. Why would that still happen? Yeah, there's like an int function. I'm just not really in love with having to do that every time I want to be sure, though. Uh... Show me for closing out of this code too early. So, okay, how about, so this is the part that I can't test for you. How I would change that piece of code just like to try it. Um, Yeah, I'm actually kind of confused by this too. Could you like? Well, even then, we don't need this Joe variable at all. Like you could just do that, I think. Like if you make the no, actually, I don't know how this input thing works. I assume it's something that's like the website gives to you that's not normally in Python. Maybe so this first input thing reads in the first line of code, or the first line of input that you then convert to an int. And then you make this string array. Do you even need the I in here at all? Could you just do that? Like if this works up here, can you just do string.append to input? Because I feel like it's an issue, something to do with how this array is being created. I guess I can copy paste it to you if you want, but yeah, I don't know how that website works, so I have a hard time like troubleshooting that part of it. Guys, there's a problem. Somebody wants to try it. Here you go. Warning, it's a little bit evil. This x, y, and z are positive reals for x plus y plus c equals c, and x, y, z are less than equal to c over 2. Wow. Yeah, so I think whatever this input function is, it's not doing what you think it's doing. So if the thing that I copy pasted in that doesn't work, I'm not sure what, because I don't really know how it works, to be honest. I'm gonna start trying this drawing. So Bode wants me to draw myself trying to solve this inequality dressed up like a prisoner, which is kind of funny. Or, you know, it's funny because it's true. You'd have to imprison me to get me to solve an inequality like that. Even though I probably will just be in there until I die of old age. Oh, he made me the prisoner hat too. Now that I think about it. Um, Whoops. I don't actually know what this is supposed to be, besides terrible. What is this inequality? Let's see if I can copy it down as faithfully as possible. A cyclic sum? I never even heard of that. Actually, I think maybe I've heard the term. Z plus y minus x squared plus x plus z minus y times y plus x minus z over 2x greater than or equal to c. I do need arms and a beard, of course. And I guess hair. Okay. Here we go. I do need to be wearing the prisoner thing. That one cartoony thing on the leg. Oh yeah, so the ball and chain. And just for fun, I'll add on that little like hat that they would have too, right? Oh dude, this marker is dying. I don't know if that even works. I've just seen like teachers do it. Dang it, dude, that marker's it's just dead. I need to replace the ink. That looks bad. I'm gonna make it blue. I got a blue ball. There we go, the little hat too. Okay. What's that? I felt something on my thumb, but it didn't seem like I had anything on it. Okay. Strictly greater than 10. Oh, good. Okay. Yeah, sorry, I was kind of out of ideas there, so I'm glad that you're able to get it fixed. Okay, I think I gotta wrap things up here, though. I didn't mean to stream for this long, but the time just keeps flying by. Let's cut the YouTube stream off here. So if you're here on YouTube, I appreciate you. I'll be back on YouTube on Tuesday. And goodbye, YouTube.